Have you ever stood before something so magnificent, so impossibly grand, that your mind struggles to comprehend how human hands could have created it? This is the feeling that overwhelms every visitor who gazes upon the Great Pyramid of Giza, a structure so precise, so massive, so enduring that for thousands of years people have wondered, debated, and theorized about its creation. And yet, the truth behind these ancient monuments is far more fascinating than any fiction we could imagine. The pyramids of Egypt stand as humanity's most enduring architectural achievement. But the story of who built them and how they accomplished this feat is not a tale of aliens or lost civilizations. It is something far more remarkable. It is the story of human ingenuity, determination, and organizational genius on a scale that would challenge even our modern capabilities. When we ask who built the pyramids, we are not asking a simple question with a simple answer. We are opening a door to an entire civilization, to thousands of workers, engineers, administrators, farmers, and dreamers who came together to create something that would outlast empires. And the evidence they left behind, carved in stone, buried in tombs, and written on papyrus, tells us a story that is finally coming into focus after centuries of speculation. The conventional answer that slaves built the pyramids under the lash of cruel pharaohs is not just wrong, it is a fundamental misunderstanding of ancient Egyptian society. And the real story, supported by archaeological evidence discovered over the past century, reveals a far more complex and fascinating picture of Bronze Age construction, religious devotion, and social organization. Let us begin with the most important pyramid, the Great Pyramid of Khufu at Giza, constructed around 2560 BCE during the 4th dynasty of Egypt's Old Kingdom, a structure that would reign as the tallest human-made building in the world for nearly 4,000 years. Who was Khufu, the man who commanded this monument's construction? He was the second pharaoh of the 4th dynasty, the son of Sneferu and Queen Hetepheres, and he ruled Egypt for approximately 23 years during what historians call the apex of the Old Kingdom, a period of unprecedented wealth, stability, and centralized power. But Khufu did not simply wake up one day and decide to build the largest pyramid in history. He inherited a pyramid building tradition that had been developing for generations, and his father Sneferu had already constructed 3 massive pyramids, learning through trial and error the engineering principles that would make Khufu's pyramid possible. The pyramid was not built in isolation. It was the centerpiece of a massive complex that included temples, causeways, smaller pyramids for queens, and an entire city built to house and support the workers. And understanding who built the pyramids means understanding this entire ecosystem of construction, provision, and administration. The question of who actually performed the physical labor of building the pyramids has been answered definitively by archaeological discoveries made over the past several decades, particularly the excavations led by Mark Lehner and Zahi Hawass at Giza. In the 1,990 seconds, these archaeologists uncovered the workers' cemetery and the remains of workers' villages near the pyramids, and what they found revolutionized our understanding of pyramid construction. The tombs in the workers' cemetery were modest compared to those of nobles, but they were not the graves of slaves. They contained the bodies of workers who had been given proper burial rites, whose bones showed signs of medical care for work-related injuries, and whose tombs were built near the pyramid itself, an honor that would never have been granted to slaves. The evidence from these graves tells us that these workers were not foreigners or prisoners. They were Egyptians who considered it an honor to work on the pharaoh's eternal resting place, and their proximity to the pyramid in death suggests they believed this proximity would benefit them in the afterlife. But who were these workers specifically, and where did they come from? The evidence suggests that the pyramid workforce was composed of several different groups, each with specific roles and skills, and understanding this organization is crucial to understanding how the pyramids were built. At the core were permanent workers, skilled craftsmen, engineers, and overseers who worked year-round on the pyramid complex. These were specialists in stone cutting, surveying, engineering, and construction management, and they formed a permanent workforce that might have numbered in the hundreds or low thousands. These skilled workers were supported by a much larger temporary workforce that rotated through the construction site, and this is where we find one of the most important pieces of evidence about who built the pyramids. Graffiti found inside the Great Pyramid, written by the workers themselves, identifies different work gangs with names like Friends of Khufu and Drunkards of Menkaure. And these inscriptions tell us that the workers were organized into large groups, perhaps 20,000 or more at a time, who worked in rotating shifts. The most compelling evidence for the nature of this workforce comes from analysis of the workers' village and the supplies that fed them. Archaeologists have found that the workers consumed enormous quantities of cattle, sheep, and goats, animals that were raised throughout Egypt and brought to Giza as a form of taxation or tribute. And the scale of this provisioning tells us that the pyramid was a national project, drawing resources and workers from across the entire kingdom. How were these workers recruited, and why would they willingly participate in such backbreaking labor? The answer lies in understanding ancient Egyptian religion and social structure, which was fundamentally different from our modern conception of labor and compensation. Ancient Egyptians believed that the pharaoh was not merely a king, but a living god, the embodiment of Horus on earth and the son of Ra. And when the pharaoh died and was properly entombed, he would join the gods and continue to ensure the prosperity of Egypt, guaranteeing the annual flooding of the Nile, the success of harvests, and the protection of the kingdom from chaos. In this context, building the pharaoh's pyramid was not slavery. It was a religious duty and a privilege. It was a way for ordinary Egyptians to participate in maintaining cosmic order and ensuring the continued blessing of the gods. The workers who built the pyramids were likely recruited through a system of corvée labor, a form of taxation where citizens owed the state a certain amount of labor rather than goods or money, and this labor was typically performed during the annual flood season when the Nile inundated the agricultural fields and farmers could not work their land. For 3 or 4 months each year, these farmers would travel to Giza, work on the pyramid, be housed, fed, and clothed by the state, and then return to their villages when the flood waters receded, and this system allowed Egypt to mobilize a massive workforce without disrupting agricultural production, which remained the foundation of Egyptian civilization. The organization required to coordinate this workforce was staggering, and it reveals a level of administrative sophistication that rivals modern construction projects. Evidence from papyri discovered at Wadi al-Jarf, an ancient port on the Red Sea, has given us unprecedented insight into the logistics of pyramid construction, particularly a papyrus written by an inspector named Merer, who was involved in transporting limestone from Tura to Giza during the final years of Khufu's reign. This papyrus, the oldest known papyrus with significant text, describes in detail how stones were quarried, loaded onto boats, transported up the Nile, and delivered to the pyramid site, and it reveals a system of incredible precision where every block was accounted for, every work gang had specific quotas, and progress was meticulously recorded. The papyrus mentions that Merer's team made multiple round trips from Tura to Giza, each trip taking several days, and that they worked in coordination with other teams to maintain a steady supply of stone to the construction site. This level of organization required not just skilled administrators, but also a system of writing, accounting, and communication that could coordinate the efforts of thousands of workers across hundreds of miles, and archaeological evidence shows that the ancient Egyptians had developed exactly such a system, with a bureaucracy of scribes, accountants, and officials who managed every aspect of the construction project. But organizational prowess alone could not build the pyramids. The ancient Egyptians also needed to solve enormous engineering challenges, and the question of how they actually constructed these monuments has fascinated engineers and archaeologists for generations. Let us start with the most basic question. How did they move the stones? The Great Pyramid contains approximately 2.3 million limestone blocks, each weighing an average of 2.5 tons, with some granite blocks in the king's chamber weighing as much as 80 tons, and these stones had to be quarried, transported, and lifted into place with Bronze Age technology. The limestone blocks that make up the bulk of the pyramid were quarried locally from the Giza Plateau itself, and evidence of these quarries can still be seen surrounding the pyramids, but the fine white limestone that originally covered the pyramid's exterior came from Tura across the Nile, and the granite used for internal chambers came from Aswan, over 500 miles to the south. How did workers armed only with copper tools quarry these massive stones? The answer lies in understanding the properties of limestone and the techniques ancient quarrymen developed. Quarrying limestone did not require cutting through solid rock with saws. Instead, workers would identify natural fracture lines in the rock and exploit them. They would cut narrow trenches around a block using copper chisels, then drive wooden wedges into the base of the block. These wedges would be soaked with water, and as the wood expanded, it would crack the stone along natural fault lines, allowing the block to be separated from the bedrock. Archaeological experiments have demonstrated that this method works remarkably well, and traces of these techniques can be seen in ancient quarries throughout Egypt. Once the blocks were quarried, they had to be moved, and this presented an enormous challenge, because the ancient Egyptians did not have wheels suitable for moving multi-ton stones. They had no iron tools, no pulleys, and no mechanical advantage beyond simple machines like levers and ramps. So how did they do it? The evidence suggests they used sledges, wooden sleds that the blocks were loaded onto, and they dragged these sledges across the ground. But dragging a multi-ton block across sand or rough ground would be nearly impossible. So the Egyptians developed a crucial technique that is depicted in ancient tomb paintings. They would pour water on the sand in front of the sledge. This might seem counterintuitive, but physics experiments conducted by researchers at the University of Amsterdam have proven that wetting the sand reduces friction dramatically, turning the sand from a loose, difficult surface into a firm, slick path that allows heavy loads to be moved with much less effort. A team of workers pulling on ropes attached to a sledge could move blocks weighing several tons, especially on the relatively flat terrain of the Giza Plateau. For stones that needed to be transported long distances, the Nile River was the key, Egypt's greatest highway and the reason Egyptian civilization flourished in the midst of desert. The Tura limestone and Aswan granite were loaded onto barges and floated down the Nile during the annual flood season when the river was high and could bring boats close to the construction site. And archaeological evidence shows that the ancient Egyptians constructed harbors and canals to bring boats as close as possible to the pyramid complex, minimizing the distance stones had to be dragged overland. The logistics of this operation were impressive. Transporting granite blocks weighing 80 tons or more would require specially constructed barges and careful calculation of weight distribution, and the fact that these blocks arrived at Giza intact and were successfully incorporated into the pyramid's structure demonstrates a sophisticated understanding of engineering and logistics. But perhaps the most impressive feat was not moving the stones horizontally but lifting them vertically, stacking 2.3 million blocks to a height of 481 feet with such precision that the pyramid's base is level to within just a few inches, and the sides are aligned to the cardinal directions with an accuracy of better than 1/15 of a degree. How did workers lift multi-ton stones nearly 500 feet into the air without cranes, without pulleys, without any of the mechanical advantages we take for granted today? This is perhaps the most debated question in Egyptology, and while we do not have definitive proof of the exact method used, archaeological and engineering evidence has allowed us to narrow down the possibilities and eliminate the wilder theories. The most widely accepted theory among Egyptologists is that the ancient Egyptians used ramps, but not a single massive ramp rising from the ground to the pyramid's peak, which would have required more material than the pyramid itself. Instead, they likely used a combination of different ramp systems at different stages of construction. Evidence suggests that in the early stages of construction, when the pyramid was still relatively low, workers might have used straight ramps leading up one face of the pyramid. These ramps would be built of mud, brick, and rubble, and would be extended and raised as the pyramid grew. But as the pyramid got higher, this method would become impractical because the ramp would become impossibly long and steep. For the upper portions of the pyramid, several theories have been proposed, and recent evidence has lent support to what is called the spiral ramp theory or the internal ramp theory. French architect Jean-Pierre Houdin has proposed, based on detailed analysis and architectural modeling, that the Egyptians used an external ramp for the first third of the pyramid's height, then switched to an internal spiral ramp that wound through the interior of the pyramid, allowing workers to continue raising blocks without building an impossibly massive external ramp. Evidence for this theory includes thermal anomalies detected in the pyramid structure that might indicate the presence of internal spaces, and microgravity surveys that have revealed density variations consistent with an internal ramp system. But this remains a theory, and the true method may have involved a combination of techniques, including counterweights, levers, and rockers that allow workers to precisely position each block once it reached the appropriate level. What is certain is that whatever method was used, it required careful planning, precise execution, and an intimate understanding of mechanics, leverage, and the properties of stone, and the proof of their success is the pyramid itself, standing after 4,500 years as a testament to their skill. But let us dive deeper into the precision that makes the Great Pyramid so remarkable, because when we examine the details of its construction, we find evidence of engineering knowledge that seems almost impossibly sophisticated for a Bronze Age civilization. The base of the Great Pyramid covers 13 acres and is almost perfectly square, with each side measuring approximately 756 feet. And the difference between the longest and shortest sides is less than 8 inches, a variation of less than 1%. And this precision was achieved without modern surveying equipment, without lasers, without even iron tools. How did ancient Egyptian engineers achieve this level of accuracy? The answer lies in careful observation of the natural world and the development of surprisingly sophisticated surveying techniques, and we know they used these techniques because they left evidence of their methods carved in stone and written on papyrus, and because modern experiments have successfully replicated their results using the same tools and methods available to ancient Egyptians. To create a perfect square base aligned to the cardinal directions, the Egyptian engineers likely used a technique based on astronomical observation, specifically tracking the movement of stars around the celestial pole. By observing the rising and setting points of a circumpolar star and bisecting the angle between them, ancient astronomers could establish true north with remarkable precision, and evidence suggests they used a tool called a merket, essentially a plumb line and sighting instrument, to make these observations and translate them into architectural alignments. To ensure the base was level, which was crucial for the pyramid's stability, they likely used water-filled channels, digging trenches around the perimeter and filling them with water. The water's surface would create a perfectly level reference line, and workers could then cut the bedrock to match this level, ensuring that the foundation was uniformly flat. And archaeological evidence shows that the bedrock beneath the Great Pyramid was indeed carefully leveled, with only the natural outcrop at the center left as a core around which the pyramid was built, saving enormous amounts of stone and labor. The precision extends beyond the base to every aspect of the pyramid's construction, and this is where we see evidence of sophisticated mathematical knowledge and engineering planning. The Great Pyramid's sides rise at an angle of approximately 51 degrees and 52 minutes, and this angle is not arbitrary. It creates specific mathematical relationships that appear throughout the structure. The ratio of the pyramid's height to its base perimeter is very close to the ratio of a circle's radius to its circumference, essentially encoding pi into the structure. And while there is debate about whether this was intentional or a natural consequence of the construction method, it demonstrates that the ancient Egyptian architects understood mathematical relationships and used them in their designs. Similarly, the pyramid's internal chambers and passages are positioned with careful attention to geometry and astronomy. The king's chamber is positioned above the pyramid's center of mass. The ascending and descending passages are aligned with specific celestial features, and the whole structure demonstrates a sophisticated integration of religious symbolism, astronomical alignment, and structural engineering. But how did the ancient Egyptians acquire this knowledge, and how did they organize the planning and execution of such a complex project? The answer takes us into the world of ancient Egyptian mathematics, astronomy, and the remarkable institution of the scribal schools where this knowledge was preserved and transmitted across generations. Ancient Egyptian mathematics was primarily practical rather than theoretical, focused on solving real-world problems in surveying, construction, accounting, and astronomy. And we know about their mathematical knowledge from several surviving papyri, most notably the Rind mathematical papyrus, and the Moscow mathematical papyrus, which contain problems and solutions dealing with areas, volumes, fractions, and practical geometry. These texts show that Egyptian mathematicians could calculate the area of a circle, the volume of a pyramid, the slope of a face, and solve complex problems involving fractions and proportions, all of which would have been necessary for pyramid construction. But mathematical knowledge alone was not enough. The construction of the pyramid required project management on a scale that would not be seen again for thousands of years, and archaeological evidence gives us glimpses into how this project was organized and executed. The workers were organized into large groups called crews, which were subdivided into gangs, which were further divided into teams, and this hierarchical organization allowed for efficient management of tens of thousands of workers. Each crew had overseers who reported to higher officials, and the whole operation was coordinated by the vizier, the pharaoh's chief minister, who was responsible for ensuring that workers were fed, housed, equipped with tools, and that materials arrived at the construction site when needed. The workers' village discovered near the pyramids provides physical evidence of this organization. The village was laid out in a planned, systematic way with barrack-style housing, bakeries, breweries, workshops for tool production, and administrative buildings. An analysis of the food remains shows that the workers were well fed, consuming beef, fish, bread, and beer in quantities that would have required enormous logistical support. Researchers have estimated that feeding the workforce at Giza would have required slaughtering 11 cattle and 37 sheep or goats per day, along with vast quantities of grain for bread and beer. And this food had to be produced throughout Egypt, transported to Giza, processed, and distributed, requiring an administrative apparatus of staggering complexity. The evidence from the workers' village also tells us something profound about the social status of pyramid builders. These were not slaves living in squalor, but workers who were valued and cared for. Their bones show that they received medical treatment for work-related injuries, including evidence of successful surgery to treat broken bones. And this medical care suggests that the Egyptian state valued these workers and invested in their health and well-being. Furthermore, the workers' tombs, though modest, were built with care and included grave goods and religious inscriptions, indicating that these workers were integrated into Egyptian society and religion, not marginalized or oppressed. This is not to say that the work was not hard. Building a pyramid was incredibly difficult and dangerous. Labor workers faced the constant risk of accidents from falling stones, heat exhaustion, and the physical toll of moving and lifting massive weights. But the evidence suggests they were compensated with food, shelter, medical care, and the religious belief that their labor was serving a divine purpose. And this combination of practical support and religious motivation was powerful enough to mobilize and sustain a workforce of tens of thousands for decades. Now, let us turn our attention to the tools and technology that made pyramid construction possible, because understanding the tools is essential to understanding how the pyramids were built, and the archaeological record has preserved not just the pyramids themselves, but also the tools that created them, giving us direct physical evidence of ancient Egyptian technology. The ancient Egyptians of the Old Kingdom were working in what we call the Bronze Age, meaning they had access to copper and bronze, but not iron. And this is a crucial constraint because copper is a relatively soft metal, far softer than the limestone and granite they were working with. So how did they cut stone with tools softer than the stone itself? The answer lies in the combination of copper tools with harder abrasive materials, particularly sand, which contains quartz crystals that are harder than both copper and limestone. When copper saws or drills were used in combination with quartz sand as an abrasive, they could effectively cut through limestone and even granite. The copper tool itself was not cutting the stone. Rather, it was holding and directing the abrasive sand particles that did the actual cutting. And experimental archaeology has demonstrated that this technique works remarkably well. Researchers have successfully cut and drilled limestone and granite using copper tools and sand, replicating the tool marks found on ancient Egyptian stonework. The evidence for these tools comes from multiple sources, including actual tools found in archaeological contexts, tool marks on stones, and depictions of workers using tools in tomb paintings and reliefs. We have found copper chisels, saws, and drills at various sites, and analysis of tool marks on pyramid stones shows patterns consistent with these implements. For example, the precise saw marks on granite blocks show the characteristic wandering pattern that occurs when a copper saw, loaded with abrasive sand, cuts through hard stone, and drill holes in granite show the spiral grooves that result from rotating a copper tube with sand. These marks are like fingerprints. They tell us exactly what tools were used and how they were employed. Beyond cutting tools, the ancient Egyptians used a variety of other implements. They had wooden sledges for moving stones, ropes made from papyrus or flax for pulling sledges, and possibly for lifting with simple machines, wooden rockers and levers for precisely positioning stones, plumb bobs for checking vertical alignment, set squares for checking right angles, and measuring rods calibrated in cubits for ensuring dimensional accuracy. These were not sophisticated tools by modern standards, but in skilled hands they were sufficient to achieve remarkable precision, and the key was not just having the tools, but having workers who were trained in their use and who understood the principles of geometry and alignment that made precision possible. The construction process itself can be reconstructed from archaeological evidence, engineering analysis, and experimental archaeology, and while some details remain debated, the overall sequence of construction is now reasonably well understood. Let us walk through the process step by step, beginning with site selection and preparation. The Giza Plateau was chosen for several reasons. It was located near Memphis, the capital of Egypt during the Old Kingdom. It was on the west bank of the Nile, the direction associated with death and the afterlife in Egyptian religion. It consisted of solid limestone bedrock that could support the enormous weight of the pyramids, and it was elevated above the Nile floodplain, protecting the pyramids from inundation. Once the site was selected, the bedrock had to be prepared. Workers would clear the surface, removing sand and loose rock, then carefully level the bedrock using the water channel method described earlier. Astronomical observations would be made to determine the cardinal directions, and the outline of the pyramid's base would be marked out with remarkable precision. Only then could actual construction begin, and this preparatory work, which left little archaeological trace, may have taken years to complete. The first stones laid were the core blocks that formed the internal mass of the pyramid. These were roughly cut blocks of local limestone, not as precisely shaped as the outer casing stones, and they were laid in horizontal courses, each course forming a complete level before the next course was begun. This method ensured stability and allowed the pyramid to remain stable even during construction, as each completed course formed a solid platform for the next. The outer casing stones, made of fine white Tura limestone, were cut with great precision and were saved for last. They would be fitted together so tightly that even today you cannot fit a knife blade between them, and they were given a final polish to create the smooth, gleaming surface that made the completed pyramid shine like a beacon in the desert sun. But these casing stones were mostly removed in later centuries, used for building projects in Cairo, which is why the pyramids today have the rough, stepped appearance of their inner core blocks. As the pyramid rose, the method of lifting stones had to evolve. The lower courses could be accessed with relatively simple ramps, but as the structure grew taller, more sophisticated methods were required. This is where the debate about internal versus external ramps becomes crucial, because the method used for the upper half of the pyramid would have determined the pace of construction and the number of workers required. What is certain is that whatever method was used, it worked. The Great Pyramid was completed in approximately 20 to 23 years during Khufu's reign. And this timeline is not speculation. It is based on archaeological evidence including dated inscriptions, the chronology of the 4th dynasty, and calculation of the construction rate needed to place 2.3 million blocks. Let us do some mathematics to understand what this timeline means in practical terms. If the pyramid was built over 20 years, and if work could only be done during the 3 to 4 month period each year when farmers were available during the flood season, that gives us approximately 60 to 80 months of actual construction time. With 2.3 million blocks to place, this means workers had to quarry, transport, and position approximately 30,000 to 40,000 blocks per month, or roughly 800 to 1,000 300 blocks per day, or 1 block every 2 to 3 minutes during a 10-hour workday. This seems impossible until you realize that these blocks were not being placed one at a time by a single crew. Instead, dozens or hundreds of crews were working simultaneously on different parts of the pyramid, each placing blocks in their section. The pyramid's massive size actually made parallel work possible. Multiple ramps could service different faces, multiple teams could work on different courses, and the work could be organized like an assembly line, with some crews quarrying, others transporting, others lifting, and others doing the precise final positioning. This kind of organization required sophisticated planning and coordination, but it was well within the capabilities of Egyptian administrators who managed the complex logistics of an entire kingdom. The evidence for this pace of work comes not just from calculation, but from archaeological discoveries, including the discovery of workers' graffiti inside the pyramid itself. These inscriptions, written in red ochre on stones that would be forever hidden inside the structure, name specific work gangs and record their progress. Inscriptions like the Friends of Khufu Gang and the Followers of the Powerful White Crown of Khufu were written by workers who took pride in their labor and wanted their contribution to be remembered, even if no one would ever see it. And these inscriptions, found in the relieving chambers above the king's chamber, provide direct evidence that the pyramid was built by organized Egyptian workers during Khufu's reign. Not by slaves, not by aliens, but by people who identified themselves by name and gang affiliation, people who were proud enough of their work to sign it. These inscriptions have also helped settle debates about the pyramid's age, because the name of Khufu appears in them, confirming that this pyramid was indeed built for and during the reign of this specific pharaoh, and radiocarbon dating of organic materials found in the mortar between stones has confirmed the 4th dynasty date, with results clustering around 2500 BCE, exactly when historical records say Khufu ruled. But the Great Pyramid was not built in isolation. It was part of a massive complex that included temples, causeways, and auxiliary structures, and understanding this complex is essential to understanding the pyramid's purpose and meaning in ancient Egyptian religion and society. Let us explore these associated structures and what they tell us about the function of the pyramid. The pyramid complex at Giza included a valley temple located near the Nile, where the pharaoh's body would first arrive by boat, a causeway, a long covered corridor that led from the valley temple up to the pyramid complex, a mortuary temple built against the east face of the pyramid where offerings would be made to the deceased pharaoh, and the pyramid itself, which housed the pharaoh's burial chamber and sarcophagus. In addition, there were 3 smaller pyramids for queens, rows of mastaba tombs for nobles and officials who wanted to be buried near their pharaoh, and boat pits containing full-size wooden boats that would allow the pharaoh to sail through the heavens with the sun god Ra. The entire complex was designed as a machine for transforming the dead pharaoh into a god and maintaining his cult forever through daily offerings and rituals. The Valley Temple is largely buried under modern Cairo, but the mortuary temple's ruins can still be seen at the pyramid's base. And these temples were not simple structures, they were massive buildings with columns, courtyards, and chambers, decorated with relief carvings and hieroglyphic inscriptions. The causeway connecting them was over 800 meters long and would have been roofed and decorated with painted reliefs, creating a processional route of extraordinary grandeur, and all of this was built at the same time as the pyramid itself, requiring additional workers, materials, and planning. The boat pits, discovered on the south side of the pyramid, contained dismantled wooden boats, including the famous Khufu ship, a 3-meter-long cedar wood vessel that was disassembled, placed in a pit, and sealed with massive limestone blocks. This boat, which has been reconstructed and is now displayed in a museum at Giza, demonstrates the ancient Egyptians' sophisticated shipbuilding technology and their religious beliefs about the afterlife. The pharaoh would need this boat to accompany Ra on his daily journey across the sky, and the fact that such a valuable object was buried shows the enormous resources that were devoted to ensuring the pharaoh's successful transition to the afterlife. Now we must address a question that often arises. Why a pyramid? Why not some other shape? And what did the pyramid mean to the ancient Egyptians? The pyramid shape was not arbitrary. It had deep religious significance. rooted in ancient Egyptian cosmology and solar religion. The pyramid was seen as a representation of the Benben, the primordial mound that emerged from the waters of chaos at the creation of the world. And it was also associated with the rays of the sun, which were thought to descend from heaven to earth in a pyramid shape. By building a pyramid, the pharaoh was creating a permanent stairway or ramp to heaven, a means by which his soul could ascend to join the gods. And the pyramid shape, with its four triangular sides meeting at a point, unified the four cardinal directions and symbolized the pharaoh's dominion over all of Egypt, upper and lower, east and west, and his connection to the cosmic order. The evolution of the pyramid shape tells us about the development of these ideas. The very first pyramid, the Step Pyramid of Djoser at Saqqara, was built about 80 years before the Great Pyramid, and it literally looks like a series of mastaba tombs stacked on top of each other, creating a stepped structure that the pharaoh's soul could climb to reach heaven. Djoser's architect, Imhotep, who was later deified for his wisdom and skill, created this revolutionary design by extending the traditional mastaba tomb vertically, and this innovation launched the Pyramid Age. The transition from step pyramids to true smooth-sided pyramids happened during the reign of Snefru, Khufu's father, and this transition was not smooth. Snefru built 3 large pyramids, and each one represents an experiment in pyramid engineering. The first was the pyramid at Mitam, which began as a step pyramid and was later converted to a true pyramid by filling in the steps with packing blocks and adding a smooth outer casing. But this pyramid suffered a catastrophic collapse, possibly during construction or shortly after, when the outer casing and packing blocks slid off the core, leaving the step pyramid core standing alone as we see it today. This failure taught Egyptian engineers important lessons about pyramid stability and the need for the outer casing to be properly bonded to the inner core. Snefru then built the Bent Pyramid at Dashur, which has a unique shape. The lower portion rises at a steep angle of about 54 degrees, but halfway up, the angle suddenly changes to a much gentler 43 degrees, giving the pyramid a bent appearance. Why did the builders change the angle halfway through construction? The most likely explanation is that they realized the steep angle was creating structural problems. Cracks have been found in the chambers of the bent pyramid, suggesting that the weight of the stone above was causing dangerous stresses, so the engineers reduced the angle to reduce the load, completing the pyramid safely, but creating this distinctive bent profile. This pyramid still stands and taught the Egyptians crucial lessons about stable pyramid geometry. Snefru's third pyramid, the Red Pyramid at Dashur, was built using the lessons learned from the previous 2. It was constructed from the beginning with a gentle angle of 43 degrees, the same angle used for the upper portion of the bent pyramid, and it became the first successful, true, smooth-sided pyramid, demonstrating that the Egyptians had mastered the engineering challenges of pyramid construction. When Khufu came to power, he inherited this hard-won knowledge, and he used it to build the Great Pyramid, but he chose to return to a steeper angle, about 52 degrees, closer to the angle of the bent pyramid's lower section. This was a bold decision that required confidence in the engineering, and the fact that the Great Pyramid has stood for 4,500 years proves that this confidence was justified. Khufu's engineers had learned how to properly bond the core blocks and casing stones, how to distribute weight evenly, and how to build on a stable foundation. And they created the largest and most perfectly proportioned pyramid ever built, setting a standard that later pharaohs would try but never quite managed to match. Khufu's son, Khafre, built the second pyramid at Giza, which appears almost as large as his father's pyramid but is actually slightly smaller. An optical illusion created because it stands on higher ground and retains more of its limestone casing at the peak. Khafre also built the Great Sphinx, that enigmatic monument with the body of a lion and the head of a king, carved from a natural limestone outcrop near his pyramid complex, and the Sphinx has its own mysteries and controversies, with some French theorists claiming it is far older than the pyramids. But geological and archaeological evidence firmly dates the Sphinx to Khafre's reign. The erosion patterns on the Sphinx are consistent with wind and sand erosion over 4,500 years, not water erosion from some hypothetical much earlier period, and the style of the Sphinx's head matches other 4th dynasty royal sculpture. Furthermore, The Sphinx sits in a quarry that provided blocks for Khafre's pyramid complex, demonstrating that it was created as part of the same construction project. The Sphinx faced east toward the rising sun, and it represented the pharaoh as a manifestation of the sun god, eternal and powerful, guarding the necropolis for all time. The third pyramid at Giza was built by Menkaure, Khafre's successor, and it is significantly smaller than the other two, suggesting that either the resources of the kingdom were diminishing or that attitudes toward pyramid building were changing, or perhaps both. Menkaure's pyramid is only about 1/10 the volume of Khufu's pyramid, and while it was still a massive construction project by any standard, it marked the beginning of a decline in pyramid size that would continue throughout the Old Kingdom. Later pharaohs would continue to build pyramids, but none would match the size and precision of the 4th Dynasty monuments at Giza, and by the end of the Old Kingdom, pyramid construction would largely cease. Why did pyramid building decline? And what does this tell us about the society that created these monuments? The answer is complex and involves both practical and ideological factors. Building a pyramid like Khufu's required enormous resources, not just materials and labor, but also a highly centralized government capable of organizing and sustaining such a project. And it required a strong ideological commitment to the divine nature of the pharaoh and the importance of his afterlife. As the Old Kingdom progressed, both of these factors began to weaken. The central government's power gradually declined as provincial governors gained more autonomy and religious ideas evolved, with greater emphasis on the democratization of afterlife beliefs. Eventually, ordinary Egyptians, not just pharaohs, could aspire to join Osiris in the afterlife, reducing the unique status of the royal tomb. The decline of pyramid building does not mean the decline of Egyptian civilization. Quite the opposite. Egyptian civilization would continue to flourish for thousands of years, producing magnificent temples, tombs, and art. But the age of the Great Pyramids was a unique moment. A brief period of about a century during the 4th Dynasty, when the that's were perfect for these massive construction projects. Strong, centralized power, abundant resources, sophisticated engineering knowledge, and absolute religious conviction about the pharaoh's divinity and the importance of his eternal rest. And the pyramids themselves became not just tombs, but symbols, reminders of Egypt's power and glory that would inspire and intimidate for millennia to come. When Greek historians like Herodotus visited Egypt nearly 2,000 years after the pyramids were built, they were already ancient monuments. And Herodotus recorded stories about their construction, some accurate, some garbled by the passage of time. He wrote that it took 100,000 men working for 20 years to build the Great Pyramid, a number that is probably too high, but shows that even in antiquity, people recognized the enormous scale of the project, and he recorded stories about Khufu that portrayed him as a tyrant who oppressed his people to build his monument. But these stories were told 2,000 years after Khufu's death, and reflect Greek assumptions about how such monuments must have been built, rather than Egyptian reality. The archaeological evidence we have today tells a different story, one of organized labor, religious devotion, and engineering brilliance, and this evidence has only come to light in the past century through careful archaeological excavation and analysis. For most of history, the pyramids were simply mysteries, massive and inexplicable, and this mystery gave rise to countless theories, some scholarly, some fanciful, some completely absurd. In medieval times, European travelers believed the pyramids were grain storehouses built by the biblical Joseph, a theory based on a misreading of ancient texts and a lack of understanding of pyramid architecture. In the 19th century, as Egyptology emerged as a scientific discipline, scholars began to seriously investigate the pyramids, measuring them, mapping them, and excavating around them. But the tools and methods of 19th century archaeology were crude by modern standards, and many important discoveries had to wait for the 20th century. The workers' cemetery and village were not discovered until the 1992nd. The papyrus of Merer was found in 2013, and new technologies like ground-penetrating radar, thermal imaging, and muon tomography are still revealing new information about the pyramid's internal structure. One of the most persistent alternative theories about the pyramids is that they were built with the help of advanced technology, either from a lost civilization like Atlantis or from extraterrestrial visitors. And while these theories make for entertaining speculation, they completely collapse under scrutiny. First, we have extensive archaeological evidence of exactly how the pyramids were built, from quarry sites showing ancient extraction techniques, to tools found in situ, to workers' villages and cemeteries, to administrative papyri documenting the logistics, to the pyramids themselves, showing evidence of the construction methods in the form of ramps, tool marks, and worker graffiti. Second, the pyramids were not built in isolation. They are part of a clear developmental sequence. We can see pyramid architecture evolving step by step, from the mastaba tombs of the early dynasties, to Djoser's step pyramid, to Sneferu's experimental pyramids, to the perfected form achieved by Khufu, and then the gradual decline in later pyramids. This is exactly what we would expect from a technology developed and refined over time by human builders, not something imposed from outside by an advanced civilization. Third, the pyramids, impressive as they are, were built with Bronze Age technology. Everything about them can be explained by the tools and techniques available to ancient Egyptians. Nothing about them requires invoking unknown technology or mysterious powers. They required enormous effort, careful planning, and skilled labor, but not magic. The persistence of these alternative theories tells us something interesting about human psychology. We are often more willing to believe in mysteries and conspiracies than to accept that ancient people were capable of great achievements, and there is something subtly racist about the assumption that ancient Egyptians could not have built the pyramids without outside help, as if brown-skinned people in ancient times were not capable of sophisticated engineering and organization. But the evidence is overwhelming that Egyptians did build the pyramids. They left us their tools, their quarries, their villages, their tombs, their inscriptions, and their pyramids, and the achievement is all the more impressive because it was accomplished with Bronze Age technology through human effort and ingenuity. Not diminished, but enhanced by the fact that it was done without modern machines or lost super technology. The pyramids stand as a testament to what humans can achieve when they are organized, motivated, and willing to dedicate themselves to a common purpose. And they remind us that our ancestors were not primitive or backward, but were intelligent, capable people who solved the problems they faced with the tools and knowledge available to them. Let us now turn to some of the specific technical achievements demonstrated by the pyramids, because when we examine them closely, we find evidence of knowledge and capabilities that continue to impress modern engineers. Consider the precision of the pyramid's orientation, aligned to true north with an accuracy of better than 1/15 of a degree. This precision was achieved through astronomical observation, probably by tracking the rising and setting points of a circumpolar star, but it required careful measurement and calculation, and the fact that this precision was maintained across the entire 756-foot base is remarkable. Modern surveying equipment can achieve similar precision, but it is sophisticated electronic instrumentation. The ancient Egyptians achieved the same result with string, wooden tools, and careful observation of the stars, demonstrating both their astronomical knowledge and their surveying skill. Or consider the internal chambers and passages of the pyramid. The king's chamber, located near the center of the pyramid, is constructed from massive granite blocks, some weighing 80 tons. These blocks were transported from Aswan, 500 miles away, brought up the Nile by barge, dragged overland to the pyramid, and then lifted more than 100 feet up into the interior of the pyramid and positioned with such precision that the chamber's walls are perfectly plumb and its ceiling is perfectly level. The king's chamber is roofed with 9 massive granite beams, each weighing approximately 50 tons. And above these beams are 5 relieving chambers, empty spaces designed to distribute the enormous weight of the pyramid above so that it does not crush the king's chamber. This is sophisticated structural engineering, showing that the pyramid's builders understood the principles of load distribution and stress management. They knew that the pyramid's internal chambers represented weak points where the massive weight above could cause collapse. So they designed relieving chambers to redirect this weight around the chambers. And their design worked perfectly. The king's chamber has remained intact for 4,500 years despite supporting millions of tons of stone above it. Modern structural engineers who have studied the pyramid's internal architecture express admiration for the ancient designers' understanding of structural principles, and some of the techniques used, such as the relieving chambers, are similar to methods used in modern architecture, demonstrating that the ancient Egyptians had developed, through experience and observation, a practical understanding of structural engineering that was sound even by today's standards. The precision with which the granite blocks in the king's chamber were cut and fitted is extraordinary. The surfaces are smooth and flat to a tolerance of a few thousandths of an inch, and the blocks fit together so tightly that you cannot insert a piece of paper between them. This precision was achieved by hand, using copper tools and abrasive sand, followed by careful grinding and polishing, and it represents thousands of hours of skilled labor. But why go to such effort? Why make the king's chamber so precise when it would be sealed inside the pyramid, never to be seen again? The answer lies in Egyptian religious beliefs. The king's chamber was not just a room. It was the sacred space where the pharaoh's body would rest for eternity, and it had to be perfect, both as an offering to the gods and as a reflection of the divine order that the pharaoh represented. Imperfection was not acceptable. Even if no living human would ever see the finished chamber, the gods would see it, and that was what mattered. And this religious perfectionism drove the ancient Egyptians to achieve technical standards that even modern craftsmen would find challenging. The passages and shafts within the pyramid also demonstrate sophisticated design and construction. The ascending passage that leads from the descending passage to the Grand Gallery is a precisely cut tunnel through solid limestone, rising at an angle of 26 degrees, and it is lined with carefully fitted blocks that create a smooth, continuous surface. The Grand Gallery, which continues the upward climb to the king's chamber, is one of the most impressive architectural spaces in the ancient world. It is 153 feet long and rises to a height of 28 feet with a corbelled roof where each course of stone projects slightly inward until the gap is narrow enough to be spanned by capstones. This corbelling technique distributes the weight of the stone above across a wider area, preventing collapse, and it creates a soaring space that would have been awe-inspiring to anyone who entered it in antiquity. The Grand Gallery is also perfectly aligned and constructed with such precision that its walls are straight and plumb despite rising through the heart of the pyramid, demonstrating the ancient builder's ability to maintain accuracy even in difficult, confined working conditions deep inside the structure. The so-called air shafts that lead from the king's chamber and queen's chamber to the exterior of the pyramid have been the subject of much speculation and study. These narrow shafts, only about 8 inches square, run through hundreds of feet of solid stone, maintaining a consistent angle and direction, and they emerge at precise points on the pyramid's exterior faces. What was their purpose? For many years they were called air shafts, suggesting they were meant to ventilate the chambers. But this seems unlikely since the chambers were meant to be sealed forever. More recent research suggests they had a religious purpose. The shafts from the king's chamber point toward specific stars that had religious significance. The northern shaft points toward the circumpolar stars, which were associated with eternal life because they never set below the horizon, and the southern shaft points toward Orion's belt, which was associated with Osiris, the god of the afterlife. These shafts may have been intended as passages for the pharaoh's soul to travel to the stars and join the gods, and their precise astronomical alignments demonstrate both the Egyptians' detailed knowledge of the night sky and their ability to incorporate this knowledge into their architecture, creating structures that function simultaneously as tombs, religious monuments, and astronomical instruments. In recent years, robotic exploration of these shafts has revealed new mysteries. In 2002, a robot explorer sent up one of the Queen's chamber shafts discovered a limestone door with copper handles, and when a camera was drilled through this door, it revealed another door behind it. What lies beyond remains unknown. And these discoveries remind us that despite centuries of study, the Great Pyramid still holds secrets. But these mysteries should not be confused with the pseudo-mysteries promoted by alternative theorists. The shafts and doors are fascinating, because they represent aspects of ancient Egyptian religious practices that we do not yet fully understand. Not because they suggest alien technology or hidden chambers full of ancient wisdom. Ongoing exploration and study will gradually reveal more about these features, adding to our understanding of ancient Egyptian engineering and religion, but the fundamental facts about who built the pyramids and how they did it are well established and supported by overwhelming evidence. Now, let us consider the question of time and construction schedules in more detail, because understanding the timeline helps us appreciate both the scale of the achievement and the efficiency of ancient Egyptian organization. We know from multiple lines of evidence that the Great Pyramid was built during Khufu's reign, which lasted approximately 23 years, and we know that pyramid construction was seasonal work, carried out primarily during the 3 to 4 month flood season when agricultural workers were available. This gives us a window of about 60 to 80 months of actual construction time spread across 23 years, during which 2.3 million blocks had to be quarried, transported, and positioned, along with the construction of temples, causeways, and auxiliary structures. This is an enormous amount of work, but it is achievable with a large, well-organized workforce, and we can estimate the size of this workforce based on the amount of work to be done and the productivity rates that have been established through experimental archaeology. Experimental archaeology involves modern researchers attempting to replicate ancient techniques using period-appropriate tools and methods, and these experiments have provided valuable data about how long various tasks would have taken. For example, experiments have shown that a team of about 20 workers with copper tools and wooden sledges can quarry a 2.5-ton limestone block in about 2 days. Once quarried, the same team can load the block onto a sledge and drag it across level ground at a rate of about 100 meters per hour, meaning that blocks quarried from the Giza Plateau itself could be moved to the pyramid site in a matter of hours. But blocks from more distant sources took much longer. The Tura limestone had to be transported by boat across the Nile, a journey of several days, and granite from Aswan had to travel 500 miles, probably taking weeks. However, not all blocks came from distant quarries. The vast majority of the 2.3 million blocks were local limestone from the Giza Plateau. Only the casing stones and the blocks for internal chambers came from Tura and Aswan. So the transportation challenge, while significant, was manageable with proper planning and organization. Lifting and positioning blocks would have been the most time-consuming part of the construction process. And this is where the exact method used becomes crucial to estimating workforce size and construction time. If we assume that ramps were used, either external or internal, then teams of workers pulling on ropes could haul blocks up these ramps. Experiments suggest that a 2.5-ton block on a slee, DGE, can be pulled up a ramp with a 1-in-1-0 gradient by a team of about 20 to 30 workers. The time required would depend on the ramp's length and the distance the block had to be moved. But a well-organized team could probably position one block every few hours. If multiple teams worked simultaneously on different parts of the pyramid, the aggregate rate of block placement could be very high, perhaps hundreds of blocks per day, which is what would be needed to complete the pyramid in 20 years. The key insight is that the pyramid's size actually facilitated rapid construction because it allowed many teams to work in parallel. Unlike a small structure where workers would get in each other's way, the pyramid's enormous footprint meant that dozens of teams could work simultaneously without interfering with each other, and as the pyramid rose, teams could work on different levels, further increasing the efficiency of parallel work. The logistics of feeding and housing a workforce of this size were as impressive as the engineering of the pyramid itself. If we estimate that the workforce during peak construction periods might have reached 20,000 to 30,000 workers, including both skilled permanent workers and seasonal corvée labor, then the task of provisioning this workforce becomes a major undertaking in its own right. These workers needed to be fed, housed, supplied with tools, and organized into effective work teams, and all of this had to happen in the desert, miles from agricultural land and water sources. The evidence from the workers' village shows that the ancient Egyptians rose to this challenge, creating a comprehensive support infrastructure that included housing, bakeries, breweries, medical facilities, and administrative centers. The bakeries found at the workers' village were industrial-scale operations. with large numbers of bread, molds, and evidence of mass production, suggesting that bread was baked in enormous quantities to feed the workforce. Similarly, the breweries show evidence of large-scale beer production, beer being a staple of the ancient Egyptian diet, nutritious, safe to drink, and easier to store than water in the hot climate. The amount of meat consumed by the pyramid workers is particularly telling. Zooarchaeological analysis of animal bones from the workers' village shows that workers ate beef, mutton, and goat meat regularly, and the bones show butchering patterns consistent with systematic meat distribution. Cattle bones are especially common, and cattle were the most prestigious and expensive meat in ancient Egypt, reserved for special occasions and elite consumption. The fact that pyramid workers ate beef regularly suggests that they were valued and well compensated. This was not subsistence rations, but relatively good food. And the amount of beef required to feed 20,000 to 30,000 workers for months at a time would have required a sophisticated system of animal husbandry, taxation, and distribution. Cattle had to be raised throughout Egypt, collected as taxes or tribute, driven to Giza, slaughtered, butchered, and distributed to the workers. And this all had to be coordinated by administrators who kept records and ensured that supplies kept flowing. The scale of this logistical operation rivals the engineering achievement of the pyramid itself, and it demonstrates the organizational capabilities of the ancient Egyptian state. The scribal bureaucracy that managed this logistics was a remarkable institution. Scribes were the educated elite of ancient Egypt, trained in reading, writing, mathematics, and administration, and they formed a professional class that managed the kingdom's complex economy. Scribes recorded tax revenues, tracked grain supplies, organized labor conscription, supervised said construction projects, and maintained the archives that allowed the state to function effectively. Becoming a scribe was one of the few paths to social advancement in ancient Egypt, and scribal schools trained young men in the skills they would need, including not just literacy and numeracy, but also the practical knowledge of surveying, accounting, and project management. The texts that survive from these schools, including mathematics problems and model letters, show that scribes were trained to handle exactly the kind of complex logistical problems that pyramid construction would present: how to calculate the number of workers needed to move a certain volume of stone, how to estimate the amount of food required to feed a workforce, how to organize workers into effective teams, and how to keep records of progress and resources. These were the practical skills that made pyramid construction possible, and they required years of training and education to master. The level of literacy required to manage pyramid construction was substantial, and this tells us something important about ancient Egyptian society. This was not a primitive or backward culture, but a sophisticated civilization with a complex bureaucracy, formal education, and specialized knowledge. The scribes who managed pyramid construction were applying mathematical and engineering knowledge that had been accumulated over generations and was taught in formal educational settings, and this knowledge was not static but was constantly being refined and improved through experience. The pyramids themselves can be seen as a form of experimental engineering. Each pyramid taught lessons that were applied to the next, and the evolution of pyramid design from Djoser's Step Pyramid to Khufu's Great Pyramid represents a learning process, a gradual accumulation of knowledge about stone construction, load bearing, stability, and design. This is how human progress works, not through sudden leaps of inspiration or gifts from advanced beings, but through patient accumulation of knowledge, careful observation, and learning from both successes and failures. The religious significance of the pyramids cannot be overstated, because understanding why the pyramids were built is as important as understanding how, and the why is rooted deeply in ancient Egyptian religion, cosmology, and beliefs about death and the afterlife. The ancient Egyptians did not see death as an ending, but as a transition to another form of existence, and they believed that preserving the body and providing for the deceased's needs in the afterlife were essential for this transition to succeed. This is why they developed mummification, why they built elaborate tombs, and why they filled those tombs with food, furniture, tools, and everything else the deceased might need in the afterlife. But the pharaoh's afterlife was different from that of ordinary people. The pharaoh was not just a human who hoped to live on after death. He was a god incarnate who would return to his divine family, and his tomb had to reflect this special status. The pyramid was not just a tomb, but a machine for apotheosis, for transforming the dead pharaoh into an eternal god. The pyramid shape itself was religiously significant. As mentioned earlier, it represented the Benben stone, the primordial mound that emerged from the waters of chaos at creation, and it symbolized the rays of the sun descending from heaven to earth. The pyramid provided a means for the pharaoh's soul to ascend to the sky, to join Ra in his solar barque, and sail across the heavens forever. This is why the pyramid's chambers and passages were oriented to specific stars and constellations. They were not just architectural features, but religious technologies, paths for the soul to follow on its journey to the afterlife. The pyramid texts, religious inscriptions found in pyramids of the later Old Kingdom, describe this journey in detail. They include spells and incantations meant to protect the pharaoh's soul, help it overcome obstacles, and ensure its successful transformation into a star in the sky. These texts are the oldest religious writings in the world, and they provide crucial insight into what the ancient Egyptians believed the pyramids were for. They were not just monuments to ego or demonstrations of power, though they certainly served those purposes too. They were fundamentally religious structures, built to serve a cosmic purpose. The cult of the dead pharaoh was an important institution in ancient Egypt, and the pyramid complex was designed to support this cult in perpetuity. The mortuary temple at the pyramid's base was staffed by priests who performed daily rituals, making offerings of food, drink, and incense to the deceased pharaoh's spirit. These offerings were essential because the ancient Egyptians believed that the dead still needed sustenance, and without regular offerings, the pharaoh's spirit might suffer or even cease to exist. The priests were supported by endowments of land that had been set aside to generate revenue for the pyramid cult, and these endowments were supposed to last forever, ensuring that the offerings would never cease. In practice, pyramid cults typically lasted for a few generations before declining, but the intention was eternal service, and significant resources were devoted to establishing and maintaining these cults. The pyramid was therefore not just a building project, but the creation of a permanent institution. And this long-term thinking is another impressive aspect of ancient Egyptian planning. They were building not just for their own lifetimes, but for eternity. The social impact of pyramid building on ancient Egyptian society was profound and multifaceted. On one hand, pyramid construction required enormous resources and mobilized a significant portion of the population, and this could be seen as a burden on society, taking workers away from productive agricultural labor and consuming resources that could have been used for other purposes. But on the other hand, pyramid construction also brought benefits. It provided employment for workers during the season when they could not farm. It stimulated the economy by creating demand for tools, food, and materials. It fostered technological innovation in engineering, surveying, and construction. And it reinforced the social order by demonstrating the pharaoh's power and the importance of the state. Moreover, the pyramid complexes became the nucleus of communities, attracting settlement and economic activity, and the infrastructure created for pyramid construction, such as roads, harbors, and administrative systems, served other purposes as well, benefiting the kingdom as a whole. The pyramids also played a role in creating Egyptian identity and unity. Egypt was a large kingdom stretching hundreds of miles along the Nile, and it encompassed different regions with their own traditions and local loyalties. But the pyramid projects brought workers from all over Egypt together, and they all contributed to a common goal: the graffiti left by workers, identifying themselves by gang names and regional affiliations, suggests that there was pride in this participation and perhaps competition between different groups to demonstrate their contribution. Working on the pyramid was a way to participate in something larger than oneself, to be part of the collective achievement of Egyptian civilization. And this shared endeavor would have reinforced the idea of Egypt as a unified kingdom under the divine rule of the pharaoh. In this sense, the pyramids were not just monuments but nation-building projects, creating social cohesion and shared identity through collective labor and shared purpose. The legacy of the pyramids extends far beyond ancient Egypt. They have fascinated every civilization that has encountered them, from ancient Greeks and Romans to medieval Arabs to modern tourists and scholars, and they have inspired countless imitations and references in architecture, art, and culture around the world. The Greeks included the Great Pyramid in their list of the 7 wonders of the ancient world, and it is the only wonder that still stands, all the others having been destroyed by earthquakes, fire, or human destruction. The Romans visited the pyramids as tourists, much as people do today, and they left graffiti recording their visits, showing that even in antiquity, the pyramids were recognized as extraordinary achievements, worth traveling to see. Medieval Arab scholars studied the pyramids and wrote accounts of them, some accurate, some fanciful, and during the Islamic period, the pyramids were sometimes quarried for building materials, with the fine limestone casing stones being removed to build mosques and palaces in Cairo. This is why the pyramids today have the rough, stepped appearance of their core blocks rather than the smooth, gleaming surface they had when first built. The modern scientific study of the pyramids began in earnest with Napoleon's expedition to Egypt in 1798, which included a corps of scholars and scientists who studied and documented Egypt's ancient monuments. The Description de l'Egypte, published after the expedition, introduced ancient Egypt to European audiences and sparked enormous interest in Egyptology throughout the 19th century. European and American scholars, adventurers, and treasure hunters explored the pyramids, often causing damage in their search for artifacts and mummies, but also gradually accumulating knowledge about their construction and purpose. The decipherment of hieroglyphics by Jean-François Champollion in 1822 was a breakthrough that allowed scholars to read ancient Egyptian texts and understand Egyptian history and religion from the Egyptians' own perspective, rather than relying on Greek and Roman accounts. And as archaeology developed as a professional discipline in the 20th century, the study of the pyramids became more systematic and scientific, with careful excavation, documentation, and analysis replacing the treasure hunting approach of earlier eras. Today, the pyramids are studied using cutting-edge technology that would have been unimaginable even a few decades ago. Ground-penetrating radar can reveal hidden chambers and voids within the pyramids without invasive excavation. Thermal imaging can detect temperature variations that indicate the presence of passages or different materials. Muon tomography, a technique that uses cosmic ray particles called muons to image the interior of the pyramids, has recently revealed a large void above the Grand Gallery in the Great Pyramid. The purpose of this void is not yet clear, but its discovery demonstrates that even the most studied archaeological site in the world can still surprise us. 3D scanning and photogrammetry allow archaeologists to create precise digital models of the pyramids and their associated structures, preserving them in digital form and allowing researchers around the world to study them without traveling to Egypt. And chemical analysis of materials, radiocarbon dating, and DNA analysis of human remains found at pyramid sites provide ever more precise information about when and how the pyramids were built and who built them. Despite all this technology and centuries of study, there are still things we do not know about the pyramids. We do not know the exact method used to lift the upper blocks. Though we have narrowed down the possibilities, we do not know the full extent of possible hidden chambers. Though ongoing exploration continues to search for them, we do not fully understand all the religious symbolism incorporated into the pyramid's design, though the pyramid texts and other religious writings give us important clues. And we do not know the names of the architects and engineers who designed the pyramids, though we know the names of some officials associated with pyramid construction from inscriptions and papyri. These unknowns are not evidence of mystery in the pseudoscientific sense. They are simply gaps in the historical record, questions that future research may answer. As new evidence comes to light and new analytical techniques are developed, this is how science works, gradually accumulating knowledge, testing hypotheses against evidence, and refining our understanding over time. What we do know with certainty is that the pyramids were built by ancient Egyptians using the technology available to them, organized through a sophisticated bureaucracy, motivated by religious belief and social obligation, and constructed through methods that we can largely reconstruct from archaeological evidence. This conclusion is not speculation or theory, but is supported by multiple independent lines of evidence that all point in the same direction. We have the quarries where the stones were cut, complete with tool marks and unfinished blocks that show the extraction process. We have the tools themselves, copper chisels and wooden sledges found in archaeological contexts. We have the workers' villages and cemeteries, showing us where the workers lived and how they were treated. We have administrative papyri, documenting the logistics of transporting materials. We have worker graffiti inside the pyramids, identifying the gangs who built them. We have the pyramids themselves, showing in their structure the methods used to build them. And we have the entire context of ancient Egyptian civilization, its religion, its technology, its social organization, all of which make sense of the pyramids as products of their time and place. The construction materials themselves tell us important stories about ancient Egyptian technology and trade networks. The vast majority of the pyramid's mass consists of locally quarried limestone from the Giza Plateau. This limestone is a relatively soft sedimentary rock that was easy to quarry with copper tools and was available in virtually unlimited quantities right at the construction site, which is one reason Giza was chosen as the pyramid site. But the ancient Egyptians did not simply use whatever materials were most convenient. They selected specific materials for specific purposes based on their properties and symbolic significance. The fine white limestone from Tura across the Nile was harder and more uniform than local limestone, and when polished, it created a brilliant white surface that would have made the completed pyramid shine in the desert sun. Visible for miles around, the symbolic importance of this gleaming white surface cannot be overstated. It transformed the pyramid from a pile of stone blocks into a representation of the sun's rays, a physical manifestation of the light that descended from heaven to earth, connecting the divine realm with the mortal world. The red granite from Aswan, used for the king's chamber and other internal structures, was chosen for both practical and symbolic reasons. Granite is much harder than limestone, making it more difficult to work but also more durable and better suited for spaces that had to support enormous loads. The king's chamber's granite ceiling has supported the weight of millions of tons of stone for 4,500 years without cracking, demonstrating the wisdom of this material choice. But granite also had symbolic significance. Its red color was associated with the sun and with life, and using it for the pharaoh's burial chamber reinforced the religious themes of solar rebirth and eternal life. The effort required to transport 80-ton granite blocks 500 miles from Aswan to Giza and then position them precisely within the pyramid's interior was enormous, but the ancient Egyptians considered it worthwhile because these blocks were not just structural elements, they were religious symbols. Every aspect of the pyramid's construction was imbued with meaning. Nothing was purely functional. Every choice of material, every dimension, every orientation had both practical and symbolic significance. The mortar used between the pyramid's blocks is another interesting material. Chemical analysis shows that it was made from gypsum, heated to drive off water and then mixed with sand and water to create a plaster-like substance. This mortar was not load-bearing. The blocks themselves support the pyramid's weight through direct contact and friction. But the mortar served important functions. It allowed workers to position blocks more easily by providing a slippery layer they could slide across, and it filled small gaps and irregularities in the block surfaces, creating a more uniform appearance and preventing water infiltration. The gypsum mortar was also used for symbolic purposes. In some areas of the pyramid, it was mixed with organic materials like charcoal, and radiocarbon dating of this organic material has helped establish the pyramid's construction date. The results consistently point to the middle of the 3rd millennium BCE, exactly when historical records place Khufu's reign, providing independent scientific confirmation of the pyramid's age and demolishing claims that it might be thousands of years older. The question of how the ancient Egyptians achieved such precision in cutting and fitting stones has been answered through careful study of the stones themselves and experimental archaeology. The surfaces of the casing stones, where we can still examine them, show evidence of having been worked with flat copper saws, probably in combination with abrasive sand. After sawing, the stones were ground and polished using stone rubbing blocks and sand. This is slow, laborious work, but it is effective. And experiments have shown that skilled workers using these methods can achieve the level of precision seen in the pyramid stonework. The key is patience and skill, not advanced technology. A skilled stoneworker who has spent years perfecting their craft can achieve remarkable precision with simple tools, and the ancient Egyptians had not just a few skilled workers but thousands of them, trained in specialized workshops where techniques were taught and refined over generations. This institutional knowledge, passed from master to apprentice, was one of ancient Egypt's most valuable resources, and it made possible achievements that seem almost miraculous when we only consider the tools without considering the human skill and knowledge that wielded them. The logistics of tool production and distribution for a project like the Great Pyramid were themselves a major undertaking. Thousands of workers needed copper chisels, wooden mallets, stone hammers, measuring rods, plumb bobs, set squares, ropes, sledges, and various other implements, and these tools wore out and needed to be replaced regularly. Copper chisels working on limestone would become blunt after a few hours of use and would need to be resharpened or replaced. Wooden tools would break, ropes would fray, and all of this required a constant supply of materials and a system for collecting worn tools, repairing or recycling them, and distributing new ones. Archaeological evidence shows that there were workshops at the pyramid site where tools were manufactured and repaired. With evidence of copper smelting, woodworking, and rope making, these workshops had to be supplied with copper from mines in the Sinai Peninsula, wood from Lebanon or from trees along the Nile, and papyrus or flax for rope making. And all of this required trade networks, administrative oversight, and skilled craftspeople. The pyramid was therefore not just a construction project, but the center of a complex economic system that linked distant parts of Egypt and even foreign regions in a web of production and exchange. The concept of state-organized labor on this scale was itself an innovation of the Old Kingdom, and it required not just administrative capability but also ideological justification. Why would workers accept being conscripted for months of hard labor on a project that directly benefited only the pharaoh? The answer lies in the ancient Egyptian concept of ma'at, a word that means truth, justice, order, and cosmic balance. Ancient Egyptians believed that the universe was constantly threatened by chaos, and ma'at was the principle that kept chaos at bay. The pharaoh was the guarantor of ma'at. His proper conduct and the performance of correct rituals ensured that the sun would rise, the Nile would flood, crops would grow, and Egypt would prosper. Therefore, maintaining the pharaoh's power and ensuring his successful transition to the afterlife was not just the pharaoh's personal concern, but a matter of cosmic importance. When workers labored on the pyramid, they were not just serving the pharaoh. They were maintaining ma'at, preventing chaos, and ensuring the continued existence of the ordered world. This religious worldview made pyramid construction not an imposition, but a duty, even a privilege. And it helps explain how such enormous projects could be carried out without massive coercion or slave labor. The administrative structure that organized pyramid construction was hierarchical and sophisticated. At the top was the pharaoh himself, who authorized the project and provided the ideological justification. Below him was the vizier, the chief minister who managed the day-to-day operations of the government, including pyramid construction. The vizier oversaw a bureaucracy of officials with specific responsibilities. There were officials in charge of labor conscription, others responsible for food supplies, others managing tool production, others overseeing quarrying operations, and still others directing the actual construction work. Each of these officials had subordinates, creating a pyramid of administration that mirrored the pyramid of stone being built. This administrative structure was documented in written records, many of which have been lost, but enough survived to give us a glimpse of how it worked. Officials wrote reports, kept accounts, issued orders, and corresponded with each other, all in hieratic script on papyrus, or in hieroglyphics on stone. And this written documentation allowed for coordination across space and time. An official in Memphis could send orders to Aswan to quarry granite, knowing that those orders would be preserved in writing and could be referred to later, and this allowed for long-term planning and complex logistical operations that would have been impossible without writing. The economic impact of pyramid construction on the Old Kingdom was significant. Pyramid building required enormous resources, but it also stimulated the economy in various ways. The need for copper tools created demand for copper, encouraging mining in the Sinai. The need for fine limestone and granite required quarrying operations that employed hundreds of workers and developed technical expertise. The need to feed the workforce stimulated agricultural production and created markets for food, the need to transport materials encouraged shipbuilding and developed Egypt's river transport capabilities, and the concentration of workers at the pyramid site created a settlement that became a permanent town. With all the economic activity that implies, in this sense, pyramid construction was a form of economic stimulus, and some scholars have suggested that it may have served a purpose similar to public works projects in modern economies, providing employment during slack periods and distributing resources throughout society. This is not to say that pyramid building was economically efficient by modern standards. Clearly, enormous resources were devoted to creating monuments rather than to productive investments, but in the context of ancient Egyptian society, where the pharaoh's afterlife was a religious imperative, and where conspicuous construction demonstrated power and piety, pyramid building made economic sense. It employed workers, demonstrated state power, and fulfilled religious obligations, serving multiple purposes simultaneously. The influence of pyramid construction on later Egyptian architecture and engineering was profound. The techniques developed for pyramid building were adapted for other monumental construction projects, including temples, obelisks, and rock-cut tombs. The organizational methods used to manage pyramid construction became standard for large state projects, and the symbolic and religious associations of the pyramid shape influenced Egyptian art and architecture for thousands of years. Even after pyramid construction ceased, the pyramid remained an important symbol in Egyptian culture, representing stability, permanence, and the connection between earth and heaven. And this symbolism was powerful enough that it spread beyond Egypt. The Nubians, who ruled Egypt during the late period, adopted pyramid building and constructed hundreds of small, steep-sided pyramids in their homeland in modern Sudan, and the pyramid shape has continued to fascinate architects and designers into modern times, appearing in buildings, monuments, and art around the world, though often divorced from its original religious meaning. The preservation of the pyramids over 4,500 years is itself remarkable and tells us something about ancient Egyptian engineering. The pyramids have survived earthquakes, sandstorms, and human interference. And while they have lost their casing stones and their peaks have been eroded, their core structure remains largely intact. This durability is due to several factors, including the pyramid's massive size, which provides inherent stability, their solid construction, with millions of tons of stone resting on solid bedrock, their shape, with sloping sides that resist tipping and distribute weight evenly, and their location in a desert environment that is generally conducive to preservation. The dry climate prevents the kind of weathering and decay that would affect stone structures in wetter environments, and the lack of vegetation means that roots do not grow into cracks and break apart the stone. The biggest threat to the pyramids over the centuries has not been natural decay, but human activity, including stone robbery, vandalism, and poorly conducted archaeological investigations. But even accounting for this damage, the pyramid's survival is a testament to the quality of their construction and the skill of their builders. When we compare the pyramids to other ancient monuments, we can better appreciate their uniqueness and understand why they have captured human imagination for so long. No other ancient civilization built structures on quite this scale or with this level of precision. The ziggurats of Mesopotamia were superficially similar, stepped pyramid structures used as temple platforms, but they were much smaller than Egyptian pyramids and were built of mud brick rather than stone, making them far less durable. None of the ancient ziggurats survive in anything like their original form. While the Egyptian pyramids still dominate the landscape, the megalithic structures of Europe, such as Stonehenge, demonstrate sophisticated engineering and astronomical knowledge, but they are tiny compared to the pyramids in terms of the volume of stone moved and the precision achieved. The closest comparisons might be the great temples and palace complexes of other ancient civilizations, but even these were built over centuries by multiple rulers, while each pyramid was the work of a single reign, typically lasting only 2 to 3 decades. The question of why other civilizations did not build pyramids on the Egyptian scale is interesting and relates to the specific conditions of ancient Egypt that made pyramid building possible and desirable. Egypt's geography was unique. The Nile provided a natural highway for transporting materials and a source of water and fertile soil that supported a large population. The predictable annual flooding created a season when agricultural workers were available for other projects, and the surrounding deserts provided both protection from invasion and an abundance of stone for construction. Egypt's political structure was also conducive to pyramid building. The highly centralized government of the Old Kingdom could mobilize resources and labor on a national scale, and the pharaoh's divine status provided religious justification for massive tomb construction. Finally, Egypt's long cultural continuity meant that architectural knowledge could be accumulated over generations, each pyramid teaching lessons that informed the next. These factors came together in a unique way in Old Kingdom Egypt. And while other civilizations built impressive monuments, none quite replicated the Egyptian achievement of the pyramids. The pyramids' impact on our understanding of ancient technology and organization has been profound. For a long time, historians tended to underestimate the capabilities of ancient civilizations, assuming that sophisticated technology and organization were modern inventions. But the pyramids force us to recognize that ancient people were capable of extraordinary achievements. The engineering knowledge required to design and build the Great Pyramid is sophisticated by any standard, involving understanding of geometry, astronomy, structural mechanics, and material science. And the organizational capability required to mobilize and manage tens of thousands of workers, coordinate the supply of materials from across Egypt, and maintain quality control over millions of individual stone blocks is comparable to the management of modern megaprojects. Recognizing these ancient capabilities changes how we view human history. Instead of seeing progress as a steady climb from primitive to advanced, we recognize that capability and sophistication have existed throughout human history, taking different forms in different contexts. Ancient Egyptians could not build computers or airplanes, but they could build pyramids, achieving in their domain a level of excellence that we can admire even if we cannot directly compare it to modern achievements. The preservation and study of the pyramids raises important ethical and practical questions that remain relevant today. The pyramids are among humanity's most important cultural heritage sites, but they face ongoing threats from urban encroachment, pollution, tourism pressure, and inadequate conservation resources. Cairo's modern sprawl has reached the edge of the Giza Plateau, and air pollution from the city is affecting the remaining limestone surfaces. Millions of tourists visit the pyramids each year, and while tourism provides economic benefits and raises global awareness, it also causes wear and tear on the monuments, people climbing on the stones, touching surfaces, and generally adding to the mechanical and chemical weathering of the structures. Conservation efforts have sometimes been controversial, with debates about the appropriate methods for preserving ancient monuments. Should interventions be visible or invisible? Should damaged areas be reconstructed or left as ruins? Should modern materials be used for conservation or only traditional ones? These questions have no easy answers, but they are important because the decisions we make today will affect whether the pyramids survive for another 4,500 years. The question of ownership and cultural heritage is also complex. The pyramids are located in Egypt and are part of Egyptian national heritage, but they are also recognized as part of humanity's shared heritage. And many of the artifacts removed from pyramid sites in the 19th and early 20th centuries are now in museums around the world, particularly in Europe and North America. This raises questions about cultural property and repatriation. Should these artifacts be returned to Egypt, or do museums that have housed and preserved them for generations have legitimate claims to keep them? There are valid arguments on both sides, and the resolution of these questions will shape how we think about cultural heritage and historical responsibility. What is clear is that the pyramids and the artifacts associated with them are too important to be considered the property of any single nation or group. They belong to all of humanity, and decisions about their preservation and interpretation should be made with the interest of present and future generations in mind, not just the interest of particular nations or institutions. The pyramids continue to inspire new research and new discoveries, and modern technology is revealing details that previous generations could not access. In recent years, advanced imaging techniques have revealed that the Great Pyramid contains previously unknown voids and cavities, suggesting that there may be hidden chambers yet to be discovered. These discoveries are made using non-invasive techniques like muon tomography, which can see through solid stone without drilling or excavation. respecting the integrity of the monument while still advancing our knowledge. Other recent discoveries include new fragments of papyri documenting pyramid construction found at sites like Wadi al-Jarf. These documents provide invaluable insights into the logistics and organization of pyramid building, confirming and expanding what we already knew from archaeological evidence. As technology continues to advance, we can expect more such discoveries, gradually filling in the gaps in our knowledge and giving us an ever more detailed picture of how the pyramids were built and what they meant to the people who built them. The story of the pyramids is ultimately a story about human capability and human meaning making. The pyramids were built because the ancient Egyptians believed that building them was necessary, that the pharaoh's successful transition to the afterlife was essential for the continued well-being of Egypt, and that creating a permanent monument to the pharaoh's glory was a worthy use of resources and labor. From our modern perspective, we might question these beliefs, but we cannot question the sincerity with which they were held or the extraordinary efforts that resulted from them. The workers who built the pyramids were not slaves forced to labor against their will, but participants in a religious project that gave meaning to their lives and connected them to something larger than themselves. The engineers and architects who designed the pyramids were not primitive savages, but sophisticated professionals who understood mathematics, astronomy, and structural mechanics, and who applied this knowledge to create monuments that have outlasted empires and continue to inspire wonder 4,500 years later. The administrators who organized pyramid construction were not cruel taskmasters, but skilled managers who coordinated complex operations involving tens of thousands of workers and resources from across Egypt. When we ask who built the pyramids and how they were built, we are asking about the capabilities and values of an entire civilization. And the answer is both humbling and inspiring. Humbling because it reminds us that our modern technology and knowledge, impressive as they are not unprecedented in human history. That ancient people were capable of extraordinary achievements that we can admire but not easily replicate. And inspiring because it shows us what humans can accomplish when they work together toward a common goal, when they combine technical knowledge with organizational skill, when they are motivated by deeply held beliefs and values. The pyramids were not built by aliens or lost civilizations or mysterious technologies. They were built by people who were much like us in their intelligence and capability, even if they lived in a very different world with very different beliefs. And that makes the pyramids not less wondrous, but more so because they remind us of the extraordinary potential of human cooperation, skill, and determination. The legacy of the pyramid builders extends beyond the monuments they created to the knowledge and techniques they developed. Ancient Egyptian engineering and mathematics influenced later civilizations, including the Greeks and Romans, who admired Egyptian achievements and learned from them. The pyramids themselves became a standard of comparison. When people wanted to describe something as ancient, massive, or mysterious, they compared it to the pyramids. And this continues today. The pyramids have become symbols, not just of ancient Egypt, but of human achievement in general. They appear in art, literature, film, and popular culture as representations of mystery, grandeur, and the achievements of the past. Sometimes these representations are accurate, drawing on archaeological and historical knowledge, but often they are fanciful, reflecting modern preoccupations and fantasies rather than ancient realities. The pyramids have become screens onto which we project our own hopes, fears, and questions about human capability and the nature of civilization. The scientific study of the pyramids has taught us important lessons about how to approach historical mysteries and how to distinguish evidence from speculation. When we encounter something we do not immediately understand, the temptation is to invoke mysterious explanations, advanced technologies, or outside intervention. But the pyramids teach us that patience, careful observation, and systematic investigation can usually provide answers that are both more mundane and more interesting than the mysterious alternatives. The real story of the pyramids, how they were built by organized teams of Egyptian workers using Bronze Age technology and sophisticated engineering knowledge, is far more fascinating than any tale of alien visitors or lost civilizations, because it is a story about real human achievement, about what people can accomplish through skill, planning, and dedication. the methods used to study the pyramids, combining archaeological excavation, historical research, experimental archaeology, and scientific analysis, have become models for how to approach other historical mysteries, demonstrating that systematic application of multiple lines of evidence can answer questions that once seemed unanswerable. The interdisciplinary nature of pyramid research is particularly instructive. Understanding the pyramids requires expertise from many fields, including archaeology, history, engineering, geology, astronomy, linguistics, and physics. No single expert can answer all the questions about the pyramids. But by bringing together specialists from different fields and having them collaborate, we can build a comprehensive understanding. This collaborative approach has revealed details that no single discipline could have discovered. For example, engineering analysis tells us what methods could have been used to lift the stones. Archaeological excavation tells us what methods actually were used based on physical evidence. Historical texts and inscriptions tell us who built the pyramids and why. Geological analysis tells us where the stones came from. Astronomical analysis tells us how the pyramids were aligned. And chemical analysis and radiocarbon dating tell us when they were built. Each line of evidence supports and confirms the others, creating a robust understanding that is far more reliable than speculation based on any single type of evidence. The debate between mainstream archaeology and alternative theories about the pyramids illustrates important principles about how we evaluate claims and evidence. Mainstream archaeology bases its conclusions on multiple independent lines of evidence, all of which point in the same direction, toward the pyramids being built by ancient Egyptians during the Old Kingdom using the tools and methods available at that time. Alternative theories, by contrast, typically rely on a small number of anomalies or unexplained details, ignore the vast body of evidence that contradicts their claims, and invoke entities or technologies for which there is no independent evidence. This is not how science works. Science does not require us to explain every single detail before we can draw conclusions. Some details may remain mysterious due to gaps in the historical record, but when we have overwhelming evidence pointing in one direction, we can be confident in that conclusion even if we cannot answer every possible question. The burden of proof lies with those making extraordinary claims, not with those proposing ordinary explanations, and extraordinary claims require extraordinary evidence, which alternative theories about the pyramids have never provided. The human stories behind the pyramids are as compelling as the engineering achievements. Every block in the pyramid was quarried, transported, and positioned by human hands. Every decision about design and construction was made by human minds, and every worker who contributed to the pyramid had a life, a family, hopes and fears, skills and weaknesses. We know some of their names from inscriptions and papyri. Workers like Merer, the inspector whose papyrus describes transporting limestone from Tura, or the anonymous workers who left graffiti identifying themselves as members of specific work gangs. These were real people, not faceless masses, and they left traces of their individuality. Even in a project as massive as the Great Pyramid, the workers' cemetery at Giza contains the graves of men who died during construction, some from accidents, some from disease, some from old age after years of service. These graves remind us that the pyramid was built at human cost, with workers risking their lives and health in service of a project they believed was divinely mandated. Their sacrifice deserves to be remembered and honored, not dismissed as slave labor or attributed to mythical outside assistance. The role of individual genius in pyramid construction is difficult to assess from the historical record. We know that the pyramids were designed by architects and engineers, but their names have mostly been lost to history. The Step Pyramid's architect, Imhotep, is an exception. His name was recorded, and he was so revered for his wisdom and skill that he was later deified and worshipped as a god of medicine and wisdom. But the architects of the Great Pyramid and other major pyramids remain anonymous, their achievements immortalized in stone, but their names forgotten. This anonymity is typical of ancient Egyptian art and architecture, which emphasize collective effort and divine inspiration rather than individual genius. But we can be certain that individuals played crucial roles. Someone had to conceive the pyramid's design, someone had to solve the engineering challenges of construction, someone had to organize the workforce, and coordinate the logistics. These individuals were geniuses by any standard, their intellectual achievements comparable to those of the great thinkers and inventors of later ages, but they worked within a cultural context that did not emphasize individual credit, and so their names have been lost, even as their work endures. The question of whether we could build a pyramid today using only ancient technology is interesting and has been partially answered by experimental archaeology. Several attempts have been made to replicate ancient Egyptian construction techniques on a small scale, and these experiments have generally been successful, demonstrating that the methods proposed by archaeologists actually work. Teams of workers using copper tools, wooden sledges, and ramps have successfully quarried, moved, and stacked multi-ton blocks, confirming that ancient Egyptians could have done the same. However, these experiments have been on a much smaller scale than the actual pyramids. Moving a few dozen blocks is very different from moving 2-3 million blocks. And organizing a few dozen workers for a few weeks is very different from organizing tens of thousands of workers for decades. So while we can confirm that the basic techniques work, we have not attempted to replicate the full scale of pyramid construction. And there is reason to doubt whether we could, not because of technological limitations, but because of social and economic ones. Modern societies organize labor very differently from ancient Egypt, and it would be difficult to mobilize and sustain a workforce of tens of thousands of people for a decades-long project using only hand tools and human labor. We have the technology to build something like the Great Pyramid using modern construction equipment, but we may have lost the social organization and motivation that made it possible for ancient Egyptians to build it without such equipment. The pyramids challenge our modern assumptions about progress and development. We tend to think of history as a story of continuous advancement, with each age building on the achievements of the previous one and surpassing it. But the pyramids suggest a more complex picture. The 4th dynasty Egyptians achieved a level of precision and scale in stone construction that was never surpassed in ancient Egypt. Later pyramids were smaller and less precisely built, not because later Egyptians had less knowledge, but because the social conditions that made the Great Pyramids possible had changed. This suggests that progress is not inevitable or unidirectional. Capabilities can be lost as well as gained, and what is possible in one era may not be possible in another. Even if the later era has more advanced technology in some areas, the pyramids were the product of specific historical circumstances, a combination of religious belief, political organization, available resources, and accumulated technical knowledge. And when those circumstances changed, pyramid building declined. This does not mean Egyptian civilization declined. It continued to flourish and create magnificent works of art and architecture, but it created different kinds of monuments suited to different circumstances and needs. The influence of pyramid building on Egyptian society extended beyond the monuments themselves to create a culture of technical excellence and precision that characterized much of ancient Egyptian art and architecture. The same attention to detail, the same concern for precision and perfection, the same integration of religious symbolism with practical function that we see in the pyramids is also evident in temples, tombs, statues, and even small objects like jewelry and furniture. This suggests that pyramid building was not an isolated achievement, but part of a broader cultural emphasis on excellence in craftsmanship, and this cultural value was transmitted across generations through the system of apprenticeship and training that characterized ancient Egyptian skilled trades. Young workers learned not just specific techniques, but also the values of precision, care, and attention to detail that made high-quality work possible. And these values became embedded in Egyptian culture, influencing not just architecture, but all forms of skilled production. The economic organization required for pyramid building also had lasting effects on Egyptian society. The system of taxation and redistribution that allowed the state to mobilize resources for pyramid construction was also used for other purposes, including maintaining the army, supporting the priesthood, and undertaking other public works. The bureaucracy that managed pyramid construction became a permanent part of the Egyptian state, managing not just construction projects, but all aspects of government administration, and the techniques of record keeping, accounting, and project management developed for pyramid construction were applied to other areas, making the Egyptian state more efficient and capable. In this sense, pyramid building was not just a drain on resources, but an investment in organizational capacity that paid dividends in other areas. The pyramids required the ancient Egyptians to develop administrative and logistical capabilities that served them well in other endeavors, from military campaigns to trade expeditions to the management of agricultural production. The religious transformation of the pharaoh that the pyramid was designed to facilitate was a complex process involving multiple stages and rituals. The pyramid was only one part of this process. The actual transformation began with the pharaoh's death and the beginning of the mummification process, which took 70 days and involved the careful preservation of the body, the removal of internal organs, the desiccation of tissues using natron salt, and the wrapping of the body in linen bandages. Each step of this process was accompanied by rituals and spells designed to protect the body and prepare it for resurrection. Meanwhile, the funeral procession would be prepared, involving priests, mourners, and the transportation of the body and grave goods from the palace to the pyramid complex. The procession would arrive first at the Valley Temple, where purification rituals would be performed, then proceed along the causeway to the Mortuary Temple, where the opening of the mouth ceremony would be performed. This crucial ritual was designed to restore the deceased senses and abilities, allowing them to eat, breathe, see, and speak in the afterlife. Only after these rituals were completed would the body be taken into the pyramid itself and placed in the sarcophagus in the burial chamber. The sealing of the pyramid after the pharaoh's burial was a significant event. The passages leading to the burial chamber would be blocked with massive granite plugs that had been held in place during construction by wooden supports. Once the burial was complete, these supports would be removed, and the plugs would slide down into place, blocking the passages and making it nearly impossible for tomb robbers to reach the burial chamber. Or so the ancient Egyptians hoped. In practice, nearly all Egyptian tombs, including the pyramids, were robbed in antiquity. Often within a few generations of their construction, the robbers were sometimes the very workers who had built the tombs and knew their layout, or they may have been officials who had access to the tomb plans. The fact that tomb robbery was common and that Egyptian authorities struggled to prevent it is documented in papyri recording tomb robbery trials from the New Kingdom. These documents describe how robbers would tunnel through walls, bypass ceiling blocks, and strip tombs of their valuable contents, including the gold and jewels buried with the deceased, and even the mummies themselves, which might be burned to extract any gold or amulets wrapped in the bandages. The robbing of Khufu's pyramid probably occurred early, possibly during the chaos of the First Intermediate Period, when central authority collapsed and local strongmen competed for power. By the time Arab explorers entered the Great Pyramid in the 9th century CE, they found the burial chamber already empty. The granite sarcophagus remained, too large to remove through the passages, but its lid was missing and there was no trace of Khufu's mummy or burial goods. Whether Khufu's mummy was destroyed by robbers or removed and reburied elsewhere by ancient Egyptian priests trying to protect it from robbery is unknown, but in either case, the pyramid's central purpose, to protect the pharaoh's body for eternity, was frustrated. This might seem like a failure, but from another perspective, the pyramid succeeded magnificently. It preserved Khufu's name and fame for 4,500 years, far longer than any treasure could have lasted. Even if his body is gone and his grave goods were stolen, Khufu is remembered. His pyramid ensures that his name will be known as long as human civilization endures. And perhaps that is a kind of immortality that the ancient Egyptians would have appreciated. The modern tourism industry around the pyramids is a significant economic factor for Egypt. Millions of visitors from around the world come to see the pyramids each year, making them one of the world's most popular tourist destinations. This tourism brings revenue and employment, but also creates challenges for conservation and management. The pyramids were not designed for millions of visitors, and the cumulative impact of tourism has caused damage. From wear on stone surfaces to changes in humidity inside the chambers that promote salt crystallization and surface deterioration. Egyptian authorities have implemented various measures to protect the pyramids while still allowing access, including limiting the number of visitors allowed inside each day, installing climate control systems in some chambers, and creating replica tombs where visitors can experience the interior without damaging the originals. These measures represent a balance between preservation and access, recognizing that the pyramids belong to all humanity and that people should be able to visit them while also acknowledging the responsibility to preserve them for future generations. The pyramids as symbols have taken on meanings far beyond their original purpose. In modern times, they have been adopted as symbols of Egypt itself, appearing on currency, logos, and promotional materials. They represent Egyptian national pride and cultural heritage, connecting modern Egyptians to their ancient past. But they have also been appropriated by various groups for their own purposes, from Freemasons who incorporated pyramid symbolism into their iconography, to New Age movements that attribute mystical properties to pyramid shapes, to marketers who use pyramid imagery to suggest mystery, power, or ancient wisdom. Some of these uses respect the pyramid's historical and cultural significance, while others trivialize or distort it, reducing complex monuments with specific historical meaning to generic symbols of mystery or exoticism. This tension between the pyramids as historical artifacts and as cultural symbols is ongoing and reflects broader questions about how we relate to the past and how historical sites function in modern society. The environmental context of the pyramids is also important to understanding them. The Sahara Desert was not always as arid as it is today. During the early Holocene period, the Sahara was much greener, with more rainfall and vegetation. But by the time the pyramids were built around 2500 BCE, the climate had already shifted to something close to its current desert state. However, the Nile Valley remained a ribbon of fertility through the desert. And this contrast between the lush valley and the barren desert was fundamental to ancient Egyptian cosmology. The desert was associated with death, chaos, and the god Seth, while the Nile Valley was associated with life, order, and the god Osiris. By building the pyramids on the desert plateau west of the Nile, the ancient Egyptians were placing them in the realm of death, the appropriate location for tombs, but the pyramids also overlooked the valley of life, maintaining a connection between the two realms. This geographical positioning was not accidental, but was deeply meaningful in Egyptian religious thought. And understanding this context helps us understand why the pyramids are where they are and what they meant to the people who built them. The hydrology of the Giza Plateau is another factor that affected pyramid construction. While the pyramid site itself is well above the Nile's flood level, water was essential for various aspects of construction, including mixing mortar, wetting sand to reduce friction when dragging sledges, and supplying the thousands of workers with drinking water. Evidence suggests that the ancient Egyptians constructed harbors and canals to bring water as close as possible to the construction site, and they may have used temporary pools and channels to distribute water across the site. Managing water in the desert environment was a significant logistical challenge, and the fact that the ancient Egyptians successfully supplied water to tens of thousands of workers for decades demonstrates their hydraulic engineering capabilities. These same capabilities were applied to managing the Nile's annual flood, building canals and reservoirs to store water and distribute it for irrigation. And this hydraulic knowledge was fundamental to Egyptian civilization's success, allowing them to maximize agricultural production and support a large population in an otherwise inhospitable environment. The social stratification of ancient Egypt is reflected in the pyramid complex. With different types of tombs for different social classes, the pharaoh's pyramid was the largest and most elaborate structure. Befitting his divine status, the queen's pyramids were smaller but still substantial, acknowledging their high status as royal wives and mothers of future pharaohs. The mastaba tombs of nobles and officials were much smaller, rectangular structures rather than pyramids, but they were still substantial stone buildings with decorated chambers, and they were positioned near the pharaoh's pyramid, allowing the nobles to remain in the pharaoh's service even in death. Ordinary workers might have simple graves marked only by a pile of stones, but the fact that they were buried in a cemetery near the pyramid rather than in their home villages suggests that their service on the pyramid was considered significant enough to merit special burial. This hierarchy of tomb types reflects the hierarchical nature of ancient Egyptian society, with clear distinctions between pharaoh, nobility, and commoners. But it also shows a degree of social integration, with all classes participating in the pyramid project and all being granted some form of burial near the sacred site. The role of religion in motivating and justifying pyramid construction cannot be overemphasized. Ancient Egyptian religion was not a matter of private belief, but a comprehensive system that structured all aspects of life, From daily routines to state policy, and the afterlife was not a distant or abstract concern, don't an immediate and pressing reality. Ancient Egyptians believed that death was not an ending but a transition, and how one was buried, and whether one's name and memory were preserved, determined the quality of one's afterlife. For the pharaoh, whose afterlife was essential for the continued well-being of Egypt, a proper burial in a magnificent tomb was not optional but necessary, and the resources devoted to pyramid construction were justified by the belief that the pharaoh's successful transformation into a god would benefit all Egyptians. This religious logic may seem strange to modern secular sensibilities, but it was entirely rational within the framework of ancient Egyptian belief, and understanding it is essential to understanding why pyramid construction made sense to the ancient Egyptians. They were not irrational or superstitious, they were acting logically, based on their understanding of how the universe worked, and their beliefs, whether or not we share them, were sincerely held and deeply meaningful. The artistic and cultural production associated with pyramid complexes was extensive. The temples and causeways were decorated with relief carvings depicting the pharaoh's achievements, religious scenes, and daily life in Egypt. These reliefs were not just decorative, but served religious and political purposes. They demonstrated the pharaoh's power and piety, they depicted the rituals that would maintain his cult, and they showed the gods accepting the pharaoh's offerings, ensuring cosmic order. The quality of these reliefs was often very high, with skilled artists creating detailed, naturalistic representations of human and animal figures, and the reliefs were originally painted in bright colors, creating a vivid visual environment that would have been very different from the bare stone we see today. In addition to reliefs, pyramid complexes included statues of the pharaoh, some of enormous size. These statues served as eternal representations of the pharaoh, allowing him to continue to receive offerings and participate in rituals even after death. The production of these statues required sophisticated stone-working techniques, including the ability to carve hard stones like granite and diorite with precision and skill, creating works of art that are still admired for their technical excellence and aesthetic power. The decline of pyramid building at the end of the Old Kingdom marks a significant transition in Egyptian history. As the central government weakened and provincial governors gained autonomy, the resources and organization required for massive pyramid projects were no longer available. During the first intermediate period, Egypt fragmented into competing regional powers, and large-scale monumental construction largely ceased. When Egypt was reunified in the Middle Kingdom, pyramid building resumed, but on a smaller scale and with different techniques. Middle Kingdom pyramids used mud brick cores with stone facings, making them cheaper and faster to build but less durable. Many Middle Kingdom pyramids have collapsed or eroded to unrecognizable mounds, while the Old Kingdom pyramids built entirely of stone still stand. The New Kingdom pharaohs abandoned pyramids entirely in favor of rock-cut tombs in the Valley of the Kings. These tombs were hidden in the desert cliffs, elaborately decorated but invisible from the surface, representing a different approach to protecting the pharaoh's burial from robbery. This shift from visible monuments proclaiming royal power to hidden tombs seeking security reflects changes in Egyptian society and the challenges of protecting royal burials in an increasingly insecure world. The technological knowledge preserved in the pyramids has practical applications even today. Modern engineers studying the pyramids have gained insights into structural design, load distribution, and the properties of materials that inform contemporary construction. The pyramid's longevity is partly due to their shape, which distributes weight efficiently and resists both vertical compression and lateral forces from earthquakes. And this principle is still relevant in modern earthquake engineering. The ancient Egyptians' use of relieving chambers to protect interior spaces from the weight of material above is a technique that has parallels in modern architecture. And their understanding of how to build massive structures on imperfect foundations, using techniques like leveling the bedrock and distributing loads evenly, remains relevant for contemporary megaprojects. The pyramids thus serve not just as historical monuments, but as case studies in engineering, demonstrating principles that remain valid across millennia and technologies. The mathematical knowledge embedded in the pyramids has been the subject of much discussion and some controversy. The Great Pyramid's proportions encode various mathematical relationships, including approximations of pi and the golden ratio, And some researchers have suggested that this demonstrates advanced mathematical knowledge that was deliberately incorporated into the design, while others argue that these relationships are coincidental, arising naturally from the construction methods used rather than from intentional design. The truth probably lies somewhere in between. The ancient Egyptian architects certainly understood geometry and proportion, and they deliberately designed the pyramid to have specific mathematical relationships, but they may not have conceptualized these relationships in the same abstract mathematical terms that we use today. Instead, they may have used practical rules of thumb and geometric constructions that produce these relationships as natural consequences. What is clear is that the pyramids demonstrate a sophisticated understanding of practical mathematics applied to real-world problems, and this understanding was sufficient to create one of the most geometrically precise large structures ever built. The astronomical alignments of the pyramids are among their most fascinating features. The pyramids are aligned to the cardinal directions with remarkable precision, and various features of their internal architecture align with specific stars and constellations that had religious significance. The alignment to true north was achieved through astronomical observation, probably by tracking circumpolar stars, and maintaining this alignment across the entire base of the pyramid requires sophisticated surveying techniques. The air shafts from the king's chamber point toward stars associated with the afterlife, and the entire pyramid complex is oriented to the east-west path of the sun, emphasizing the solar associations of the pharaoh and his identification with Ra, the sun god. These astronomical alignments demonstrate that ancient Egyptian architects understood the movements of celestial bodies in considerable detail and could predict their positions with accuracy. This astronomical knowledge was both practical, allowing for precise orientation of structures, and religious, connecting earthly monuments to cosmic order and divine power. And it represents another area where the ancient Egyptians achieved a level of sophistication that commands respect even by modern standards. The question of what the ancient Egyptians themselves thought about the pyramids after they were built is fascinating, but difficult to answer. We have few records of Egyptian reactions to the pyramids from the Old Kingdom when they were new, but later Egyptian texts sometimes mention them with admiration, suggesting that even ancient Egyptians, looking back at the achievements of their ancestors, were impressed. During the New Kingdom, more than 1,000 years after the pyramids were built, they were already ancient monuments and tourist attractions. New Kingdom visitors left graffiti on pyramid walls, recording their visits much as modern tourists do, and some New Kingdom texts express wonder at the skill of the old builders, recognizing that something had been lost and that the ancestors had achieved things that later generations could not replicate. This suggests that the ancient Egyptians themselves experienced something like the awe that modern visitors feel, recognizing the pyramids as extraordinary achievements that connected them to a glorious past. The pyramid builders left us not just monuments, but also a legacy of innovation and problem solving that remains relevant. Faced with the challenge of moving and lifting millions of tons of stone with only Bronze Age technology, they developed practical solutions that worked. When faced with structural problems, as in the bent pyramid, they analyzed the issue and adjusted their approach, demonstrating flexibility and learning from experience. When faced with logistical challenges of feeding and housing tens of thousands of workers, they created administrative systems and supply chains that functioned effectively for decades. And when faced with the religious imperative to create eternal monuments, they combined engineering skill with religious symbolism to create structures that served both practical and spiritual purposes. This legacy of innovation, adaptation, and problem solving is perhaps more valuable than any specific technique or technology because it demonstrates a mindset, a way of approaching challenges that remains applicable regardless of the specific tools or constraints we face. The collaborative nature of pyramid construction is another important legacy. Building a pyramid required cooperation among thousands of workers from different regions with different skills, working toward a common goal. This required communication, coordination, and mutual respect. Workers had to trust the engineers' designs. Engineers had to rely on workers' skills. Administrators had to ensure that supplies arrived when needed, and everyone had to believe that their contribution mattered. This kind of large-scale cooperation is difficult to achieve and maintain. and it speaks to the social cohesion and organizational capability of Old Kingdom Egypt. Modern megaprojects, from building skyscrapers to constructing space stations, require similar cooperation, and the pyramids remind us that such cooperation has always been essential for great achievements. Humans accomplish more together than we ever could individually, and creating the conditions for effective cooperation, including clear communication, competent leadership, and shared purpose, is as important as any technical knowledge. The preservation of knowledge across generations was crucial to pyramid building. Each pyramid built on the lessons learned from previous pyramids, and this required a system for transmitting knowledge from one generation of builders to the next. This was accomplished through apprenticeship, where young workers learned from experienced masters, through written records, including architectural plans and administrative documents, and through the physical monuments themselves, which served as three-dimensional textbooks showing future builders what had been achieved and how. This transmission of knowledge allowed ancient Egyptian civilization to accumulate technical expertise over time, with each generation standing on the shoulders of the previous one. And it is a reminder of the importance of education and knowledge preservation for any civilization that hopes to progress. Without mechanisms for preserving and transmitting knowledge, each generation would have to start from scratch. But with effective knowledge transmission, achievements can build on each other, leading to ever greater accomplishments. The pyramid's influence on later architecture extends far beyond ancient Egypt. The pyramid shape has been used in various cultures and eras, sometimes with knowledge of Egyptian originals and sometimes independently. The step pyramids of Mesopotamia, the Maya pyramids of Central America, and various modern buildings using pyramid forms all demonstrate the appeal of this shape, whether as a structural solution, a symbolic statement, or an aesthetic choice. In modern times, pyramid-shaped buildings have been constructed around the world. From the Louvre Pyramid in Paris to the Luxor Hotel in Las Vegas, these modern pyramids reference ancient Egypt explicitly, borrowing its symbolic associations of permanence, mystery, and grandeur. And while they are built with modern materials and technology, they demonstrate the continuing power of the pyramid form to capture imagination and convey meaning. The ancient Egyptian pyramids set a standard and created an archetype that continues to resonate thousands of years later. The question of cultural memory and historical consciousness is raised by the pyramids' extreme longevity. The pyramids have outlasted the civilization that built them, ancient Egyptian civilization, in the form that built the pyramids, ended thousands of years ago. Yet the pyramids remain, and they have shaped how we remember and understand that civilization. For most of history, the pyramids were the primary or only evidence most people had of ancient Egypt's existence and capabilities, and they created an image of ancient Egypt as a civilization of builders capable of monumental achievements. This image has been both accurate and limiting. Accurate because the ancient Egyptians certainly were capable builders, but limiting because Egyptian civilization achieved much more than pyramids in art, literature, mathematics, medicine, and other fields. Yet the pyramids' visibility and durability ensured that they dominated cultural memory of ancient Egypt. This reminds us that what survives from the past shapes how we understand it, and that our understanding is always partial, based on the fragments that chance and durability have preserved. The ethical dimensions of studying and displaying artifacts from pyramid sites raise important questions. Many artifacts removed from Egyptian sites in the 19th and early 20th centuries are now in museums around the world. And while these museums have preserved and studied these artifacts, there are valid questions about whether they should be returned to Egypt. These questions involve balancing several considerations, including Egypt's right to its cultural heritage, the role of museums in preserving and sharing knowledge globally, the historical circumstances under which artifacts were removed, and the practical questions of conservation and access. There are no easy answers, but the debate itself is important because it forces us to think about who owns the past and who has the right to study, display, and interpret it. The pyramids themselves, being immovable, remain in Egypt, but the artifacts associated with them have scattered around the world, and resolving questions about their proper home requires balancing national heritage claims with the idea of cultural heritage as belonging to all humanity. The pyramids, as sites of continuing scientific investigation, remind us that our understanding of the past is always evolving. New technologies allow us to ask new questions and find new answers, and each generation of scholars brings new perspectives and methods to the study of these ancient monuments. The discovery of the workers' villages in the 1990 seconds fundamentally changed our understanding of who built the pyramids. The discovery of the Mera papyrus in 2013 provided unprecedented detail about construction, logistics, and recent imaging studies revealing internal voids suggest that there may still be significant discoveries waiting to be made. This ongoing research is not just about satisfying curiosity, but about understanding human capability and achievement. The pyramids set a standard for what humans can accomplish, and understanding how that standard was achieved can inspire us to tackle the challenges we face today with similar ingenuity and determination. The interdisciplinary collaboration required for modern pyramid research is itself a testament to how far our methods have evolved. Egyptologists work with geologists to identify stone sources, with chemists to analyze mortar and dating samples, with astronomers to verify alignments, with engineers to test construction theories, with medical specialists to study worker remains, with climate scientists to understand the environmental context, and with digital specialists to create 3D models and virtual reconstructions. This collaborative approach mirrors the collaborative nature of pyramid construction itself, where different specialists, from quarrymen to surveyors to priests, had to work together to achieve a common goal, and it demonstrates that complex problems, whether in ancient construction or modern research, require bringing together diverse expertise and perspectives to find solutions. The pyramid's role in the development of Egyptology as a scientific discipline is significant. The early exploration of the pyramids in the 18th and 19th centuries helped establish the methods and standards that would define archaeological practice. The careful measurement and documentation of pyramid dimensions by scholars like Flinders Petrie set new standards for precision in archaeological recording. The stratigraphic excavation methods developed at pyramid sites helped establish principles of archaeological stratigraphy that are still used today, and the interdisciplinary approach to studying pyramids, combining textual analysis, material culture studies, and scientific analysis, became a model for studying other ancient sites. In this sense, the pyramids were not just objects of study, but catalysts for the development of new methods and approaches, and they continue to serve this role, with cutting-edge technologies often being tested first on pyramid research before being applied elsewhere. The psychological impact of the pyramids on visitors, both ancient and modern, is worth considering. Standing before the Great Pyramid, one is struck by its sheer size and the precision of its construction, and this physical experience creates an emotional response, a sense of awe and wonder at what humans can achieve. This response is not intellectual, but visceral. The pyramids overwhelm us with their scale and endurance, making us feel small and temporary in comparison. Yet this feeling is paradoxically uplifting rather than depressing. Because the pyramids were built by humans like us, they demonstrate that we are capable of creating things that transcend individual lives and endure for millennia. They connect us to the vast sweep of human history and remind us that we are part of something larger and longer lasting than ourselves. This emotional impact is part of why the pyramids continue to fascinate people around the world. They are not just historical artifacts or engineering marvels, but sources of inspiration and meaning. The pyramids, as economic engines in ancient Egypt, had effects that rippled throughout the society. The demand for materials created markets and stimulated production in quarrying, mining, and forestry. The need to transport materials encouraged boat building and river commerce. The requirement to feed workers stimulated agricultural production and created demand for food distribution systems. The concentration of workers at Giza created a market for goods and services, from pottery to textiles to entertainment, and the administrative systems developed to manage pyramid construction found applications in other areas of government, making the state more efficient and capable. In these ways, pyramid construction was not just a drain on the economy, but a stimulus that encouraged economic development and organizational innovation. The resources devoted to pyramids were not wasted, but were invested in building the capabilities and infrastructure that allowed Egyptian civilization to prosper for thousands of years. The spiritual and philosophical questions raised by the pyramids remain relevant today. The ancient Egyptians built the pyramids because they believed in an afterlife and wanted to ensure their pharaoh's successful transition to it. This belief motivated them to undertake enormous labors and create monuments that would outlast their civilization. Modern people may not share these specific religious beliefs, but we still grapple with questions about meaning, legacy, and what we leave behind. The pyramids force us to ask what we value enough to devote enormous resources to, what we want to preserve for future generations, and what we hope will outlast us. These are not just ancient questions, but perennial human concerns, and the pyramids stand as one answer. The ancient Egyptians chose to invest in permanence, in creating monuments that would endure and preserve their civilization's achievements and values for all time. And the fact that we are still studying and admiring these monuments 4,500 years later suggests that they succeeded in their goal. They created something truly permanent that continues to inspire and inform us millennia after its builders passed away. The craftsmanship visible in pyramid construction, from the precision cutting of stones, to the careful alignment of passages, to the detailed relief carvings in temples, reflects a cultural value on excellence and perfection that characterized ancient Egyptian civilization. This was not just about creating functional structures, but about creating works of art and religious significance that had to meet the highest possible standards. The workers who built the pyramids were not just laborers, but craftsmen who took pride in their work. And this pride is evident in the quality of their output. The fact that they inscribed their gang names inside the pyramid, where no one would see them, shows that they cared about their work for its own sake, not just for external recognition. This craftsmanship ethic, the idea that work should be done well because it is worth doing well, is a value that transcends time and culture. And it is part of what makes the pyramids so impressive. They represent not just brute force or massive resources, but care, skill, and dedication to excellence. The pyramid's relationship to power and authority is complex and multifaceted. On one level, they were demonstrations of the pharaoh's power, physical proof that he could mobilize the resources and labor of an entire nation to create his tomb. And this demonstration of power served political purposes, intimidating potential rivals and impressing subjects and foreigners with the might of Egypt. But the pyramids were also religious structures built to serve divine purposes and ensure cosmic order. And in this sense, they represented not just human power, but the pharaoh's role as intermediary between humans and gods. The scale of the pyramids reflected not just the pharaoh's earthly power, but his cosmic significance. And this dual nature, as both political statement and religious monument, is essential to understanding what the pyramids meant to the ancient Egyptians. They were not just tombs or propaganda, but sacred structures that served both earthly and divine purposes, maintaining the relationship between the human and divine realms that was central to Egyptian religion and kingship. The technical innovations developed for pyramid construction had applications beyond building pyramids. The surveying techniques used to align the pyramids could be applied to other construction projects and to land surveying for agriculture and taxation. The organizational methods used to manage pyramid construction could be applied to managing armies, organizing irrigation projects, and coordinating other large-scale activities. The material science knowledge gained from selecting and working different types of stone informed other areas of Egyptian technology, from sculpture to jewelry making, and the mathematical knowledge developed and applied in pyramid construction was taught in scribal schools and used for various practical purposes, from calculating field areas to determining tax obligations. In these ways, pyramid construction served as a driver of innovation and a training ground for developing capabilities that served Egyptian civilization more broadly. The pyramids were not isolated projects, but were integrated into the larger economy and society, contributing to its overall development and sophistication. The democratic impulse visible in some aspects of pyramid construction is worth noting. While ancient Egypt was hierarchical and authoritarian by modern standards, the fact that ordinary workers could participate in building the pharaoh's pyramid, that they were well fed and cared for, and that they were buried near the pyramid with proper funerary rites suggests a degree of social integration and mutual obligation that tempered pure authoritarianism. The workers were not just exploited, but were valued members of society whose contribution was recognized and honored. And this created a sense of shared purpose and common identity that bound Egyptian society together. The graffiti left by work gangs, with their boastful names and expressions of pride, shows workers who felt themselves to be important participants in a great enterprise, not mere tools to be used and discarded. And this suggests that ancient Egyptian society, while certainly not democratic in any modern sense, had mechanisms for incorporating and valuing the contributions of ordinary people, at least in the context of great collective projects like pyramid building. The environmental impact of pyramid construction was significant. Quarrying millions of tons of stone from the Giza Plateau transformed the landscape, leaving quarries that are still visible today. The demand for wood, for sledges, rollers, scaffolding, and boats contributed to deforestation in regions where Egypt sourced timber. The concentration of tens of thousands of workers and animals at Giza would have created waste management challenges and affected local ecosystems. And the diversion of labor from agriculture to construction, even if only seasonal, would have affected land use patterns. However, these environmental impacts were small compared to the impact of modern industrial activity, and they were sustainable in the sense that they did not prevent Egyptian civilization from continuing to thrive for thousands of years. The ancient Egyptians managed to balance monumental construction with agricultural production and resource management, demonstrating that it was possible to undertake great projects without destroying the environmental base that supported them. And this is a lesson worth remembering in our own time, when we face the challenge of pursuing development while preserving environmental sustainability. The pyramids as educational resources continue to serve humanity. They are studied in schools around the world as examples of ancient achievement. They feature in documentaries and books that bring ancient history to life for general audiences. They inspire scientific research that advances our understanding of the past, and they serve as case studies in engineering, architecture, project management, and various other fields. This educational value is enhanced by the fact that the pyramids still stand and can be visited, making them tangible connections to the past rather than just abstract historical information. Students who visit the pyramids or even just see pictures of them have a concrete example of what ancient people achieved, and this can inspire interest in history, archaeology, engineering, or any number of other subjects. The pyramids thus continue to serve a purpose for humanity, not the purpose their builders intended, but a valuable purpose nonetheless, connecting us to our past and inspiring us to understand and appreciate human achievement across time and culture. So when we ask who built the pyramids and how they were built, we are ultimately asking about human potential and what we can achieve when we dedicate ourselves to a goal. The answer is that the pyramids were built by thousands of ordinary Egyptians, farmers and craftsmen and laborers, organized by skilled administrators, designed by brilliant engineers and architects, motivated by religious belief and social obligation, using Bronze Age tools and sophisticated techniques, working for decades to create monuments that would outlast their civilization and inspire humanity for millennia. This is not a mysterious answer or a disappointing one. It is a profound and inspiring answer, because it tells us that the pyramids are not the work of gods or aliens or lost super civilizations, but the work of people like us, people who solve problems, who learn from experience, who work together toward common goals, who took pride in their craft, and who created something that transcended their individual lives to become part of the permanent heritage of humanity. The pyramids stand today not just as tombs or monuments, but as testaments to what humans can achieve through intelligence, organization, skill, and dedication. And they challenge us to ask what we, with all our modern technology and knowledge, will leave behind for future generations to marvel at and learn from. Will we build our own pyramids? Not necessarily physical monuments, but achievements in science, art, social organization, or environmental stewardship that will benefit humanity for generations to come. Or will we squander our resources and capabilities on ephemeral concerns that will be forgotten as soon as we are gone? The pyramids, built 4,500 years ago by people with copper tools and wooden sledges, force us to confront these questions and to measure our own achievements against theirs. And in doing so, they continue to serve the purpose of challenging and inspiring humanity, connecting us to our past while pointing us toward our future, reminding us that we are capable of extraordinary things if we are willing to work for them, and that the greatest achievements are those that outlast us and contribute to the permanent advancement of human civilization. The ancient Egyptians understood this. They built for eternity, and their pyramids, standing against a desert sky after 45 centuries, prove that they succeeded beyond even their own ambitious dreams. For they created not just tombs but immortality, not just monuments but inspiration, not just structures but symbols of human achievement that will endure as long as human civilization exists to appreciate them.